a USB stick that we can send around, and you can add that to your collection of stuff. We're going to talk in depth about where to find VisionEval online because we're actively developing and all the rest. I'll come back to that. Okay, reset. I'm getting ahead of myself. So, okay. Well, we'll see what we can do here. With luck, it's going to work out on the other end. So lessons all over the place. VisionEval is a work in progress, and so this workshop is a work in progress, and I'm glad you're all here doing the work with us. Okay, Dan, let's hit it. And I'll wait a second just for that to happen. And welcome to the VisionEval training. This is the end user training where you in this room, future users of VisionEval, get to learn what it is, how you get it, how you use it, what you can do with it, and what you can't do with it, all of which are important things. I mean, there are things that you might be inclined to do with it that you can't. And we'll talk about those because the things you can do with it are really cool and very important to the planning process. So we're going to start out with introductions. So first of all, I've been up here rattling away. Some of you have no idea who I am. I'm Jeremy Raw. I work for the Federal Highway Administration in our Office of Planning. The kind of stuff I do is technical support work for all kinds of things related to travel forecasting, data analysis, applications of technology in the transportation planning process. VisionEval has been casually one of my projects for a long time and officially one of my projects for, I guess, about the last 2.5 years after we set up a pooled fund to further develop the product. And so I've been the project manager for that for Federal Highway. Along the way, I've ended up going from being one of you sitting in a room like this listening to the people who really know about VisionEval talk about it, to being somebody who at this point probably knows more about VisionEval than any human being has a right to do if they weren't one of the original developers. And we've got one of those sitting in the room today, but we won't blow the cover just yet. So that's where I am. And I think I'm going to introduce my co-presenter this morning, Tara Widener from Oregon DOT, who knows more about VisionEval than me, although she won't confess it. But she'll end up demonstrating as part of our workshop.
Yeah, so I'm Tara Widener from the Oregon Department of Transportation, and I have been working on this since about 2013. So it was models that were developed in Oregon, and now they've become a national pooled fund, so that's very exciting. And we're at like kind of a level with an open source tool now, and ready to kind of roll it out and get more people using it. So it's great to see a lot of people here.
Right. We're very excited about this. We have a phone line open because, as I said, we're trying to record this thing. And sitting out on the phone line, if you hear this little voice in the background a while ago going, wait, something's gone wrong. That's Dan Flynn out at the Volpe Center. Dan's one of my technical support backup at Federal Highway. Hi, Dan.
Hi, everybody.
So that's the little voice you may occasionally hear, probably if things are going badly off the rails with respect to the recording. But we hope that Dan just gets to sit there and sip on his cup of coffee all morning. And probably where we're headed is we're going to start by talking general concepts of VisionEval. And we're going to explain why does this model exist, what is it intended to do, and a little bit about how it differs from other models and modeling approaches that you may have heard of or worked with before. I mean, frequently, folks who do planning models will often work with travel demand models and various forms of sketch tools. VisionEval kind of lands in the world of sketch tools, but what it can do and the kinds of applications it's intended for are really rather different. I mean, the idea of a sketch tool, back of the envelope calculation, we can make a guess as to how many more VMT we're going to have. And so I know that VMT is related to population and jobs, and I've got a scale factor, and if we have more population, more jobs, I get a better number. If we start with that and say, but, we know a lot more about the population than just people and jobs, we can do more than that. And there are new applications for this in the sense that what comes out the back end is not just about knowing a number. It's about understanding a process and understanding where those numbers came from. So what we're going to do as we go into this will be to discuss that larger context. That's the first piece we're going to do. And we're going to explain a bit about how Oregon has been using this at the DOT and think a little bit about where the applications for this model lie. That's the design considerations part. Following that, we're going to turn around and say, okay, so what is this thing? And we're going to talk about where you get the software, how you install it on your computer, and what's there after you've installed it. And I will show you some things about running with it, which will probably just like go in one eye and out the other, in the sense that it won't make sense to you immediately about why are these pieces here, what do they actually do. By the time we get to the end, if we have time before this is all over, we will come back and look again at all of this stuff, and it will make a lot more sense to you. And if we don't have time to do that, you can do it on your own, and trust me, it will make more sense to you. So we'll be using the tool piece. It says 60 minutes. I'm hoping it'll be a little less than that, because really where the meat of this presentation is that fourth item, review key concepts. We're going to talk about what are we thinking about when we use VisionEval. What are the problems that we're trying to solve? What are the things we're trying to learn from using the tool? Because those are a little different than what we've classically thought of when we start doing forecasting models. Now, and we'll discuss as we get into the design considerations why we do things differently with this model and what we can get out of it that wasn't available to us before, and that in my view actually ends up being critically important to the problems that we're facing as transportation planners today. Finally, at the end, resources and wrap up, we will remind you again of where you can get the tools, where you can find out more information. We're in the process of building, we already have an enormous documentation library. It's not super well organized, so we're organizing it, we're writing better stuff, coming up with things for beginners and intermediate people to kind of walk them through the process and the understanding of where this goes. So we'll show you those things at the end. We will revisit the tool stuff in particular so you can get a feel for, okay, now I understand the pieces. Let me see where they all are.
So I started to mention this already, that classically speaking, we have had sort of different approaches to doing modeling. And one of them is sketch models, and I described this briefly, the back of the envelope calculation to make a guess about some number that might be relevant for your planning purpose. I mean, just how big is that number going to be? Second thing that we've had going on, though, has been an emphasis in transportation planning on really trying to understand not just the results, but the process by which we get to them. I'm looking at this box called activity-based model on the lower left there. The idea there is to understand that different people with different characteristics will have different needs in response to the transportation system, and they will respond differently to what they find there. That a household with kids who are in school will travel differently than a household that consists, say, of a single young person who's in a job, or a couple of senior citizens, or a single senior citizen, or whatever. So we have characteristics like that. Income is a factor that will change how people use the system. Availability of resources will also make a difference, and it will affect different demographics differently. If we provide more transit service in a lot of places, I'd say Portland is sort of exceptional within the city, because I think people use transit here who, where I live in Richmond, Virginia, would never be caught on a bus if their life depended on it. So that's, those are factors that we want to take into account and think about the opportunities that are available, who's susceptible to those opportunities, and make estimates that are respectful of those pieces. Classically, over the last 20 years in transportation planning, we've developed this class of rather large regional forecasting models called activity-based models that will unpack the households and the population and the economics and really do nuanced estimates of behavioral demand and what people are doing with this stuff. Classically, these are, and I'll use this phrase gently and nicely, lumbering behemoths, if I can put it that way. They're expensive and difficult to set up. It's hard to change the scenarios. There's a lot of input, and the reward you get for doing all that work is you get an enormous detail on the back end about what's going on. The catch is that those models tend to be very dependent on a lot of assumptions about what the future is going to be like, how people are going to respond, and a lot of the detail you get out of them is, for many respects, illusory in the sense that we're not absolutely sure that the scenario that we spent all these months coding up in the model is actually going to be the one that comes out. And as I will point out again in a minute, the trouble with a lot of the planning problems that we're facing, and this goes everywhere from greenhouse gases to self-driving cars, are things that could go lots of different ways. And when we start trying to assess what the effects might be, we don't have a clear way of really settling on that scenario. And a lot of the stuff that we might put into these big models ends up being very speculative and perhaps nailing us to a wrong idea as we start to gather data about this and really see what's going on, about what's possible and what might be the outcome. The other place that VisionEval starts from is this world of integrated models. And this is, when I say integrated model, it is a question of looking at land use and transportation and some of the determinants of travel behavior that go beyond the classic, oh, I need to go to my job. Well, where is your job? Where are you living? I mean, I already described the difference between, say, Portland and where I live in Richmond, Virginia, with respect to transit usage. That in some ways, my decision about whether or not to use the bus isn't just about me as a person or part of a household or anything else. It's about where I live, what the opportunities are, and changing my location will change whether I use the bus, how inclined I am to use the bus, how available that stuff is. And it's not just a question of the background supply. That we'll go out there and say, we're going to do a certain amount of new development, but that new development of transportation stuff inspires people to build new stuff in terms of houses, jobs, other activities. And so we want to try and model that because it's actually really important. In a state like Oregon, where you have growth boundaries, for example, around places like Portland, making decisions about the growth boundaries, making decisions about what to do with transportation and land use is absolutely critical. And even places that have this as a less formal process want to wonder about that. One of my jobs at Federal Highway is reviewing forecasts for environmental impact statements. One of the places we always get caught up on this is if you build a big new transportation facility, the land use changes. And you have to acknowledge that. And so one of the places we've looked at, and I've done it at Oregon DOT with the SWIM model, right, the statewide integrated model, that looks at economic forces, looks at the development of land, looks at the needs that emerge for transportation. So we've got all of these different needs, and again, and I'll say the other catch with the integrated models, like the activity-based models, is they're big, cumbersome things that require a lot of setup. And what we're looking at is this magic world that will somehow give us the advantages of a sketch model in the sense that we can turn stuff over quickly, the advantages of an activity-based model in the sense that we can really unpack what are the forces and determinants for this population in this place with these facilities, and what's available to them. And then the integrated model where we can consider factors that are not strictly just road characteristics. We're going to look at that larger interaction economically between what's being built, what the effects are, and how that might carry over back and forth between land use and transportation. So what we've done in VisionEval actually is set up a system that has the virtue of the sketch model, runs fast, has the virtue of the activity-based model in the sense that we really take apart the population and understand the determinants, and has the virtue of the integrated model in that we're going to consider factors that may go beyond traditionally things that we put into travel demand models. Now, and we're going to do this so that we can get to the box that's right down here at the bottom that says scenario variance. Because as I was mentioning, the big piece that we have, and I'm going to tell you the spectrum, greenhouse gases, automated vehicles, micro-mobility, the stuff coming up with scooters and bike shares. And I mean, this is one of the things that we have Liming looking at that we'll talk about this afternoon. That there are lots of things going on. I mean, the death of brick and mortar retail that everybody talks about, drone delivery of commercial goods. They're just starting to hand out licenses for that kind of stuff. Virginia had a pilot project I read about in the newspaper this morning, where they're going to have Walmart flying little things to drop packages on your doorstep. I'm like, okay, this is going to be cool. What does it mean? And we don't actually know, but we've got an idea. And so this is a place where we can actually start looking at lots of possibilities. Because VisionEval is, relatively speaking, a fast-running model, we can turn around a few hundred scenarios in the space of time that it would have taken us to do one activity-based model run. And we can look at lots of combinations of alternatives, look at lots of different possibilities and say, people could go all in on this shared mobility thing and they give up their cars and they're just using Ubers and Lyfts. What would happen if? And we can describe that with the model, run the outcomes to see, what are the possibilities, look at pricing strategies, look at things that we could intervene with in different ways, and crank out 150 possibilities, 1,500 possibilities, and view the combinations of the results and see what happens. You're looking at your watch because I love to talk, and so and I get excited about this because I mean, for me, where I sit in the planning and I work with lots of agencies around the country, these are the questions they've got, and these are the problems they're trying to deal with. It's not about knowing what the future is going to be in detail. It's about understanding the risks and opportunities that are available to us based on people adopting these new transportation technologies and us responding in the ways that we have available. So I've already said all of that. Let's see if I missed anything on this list. Oh yeah, open science approach, right? Well, actually, I could go through all of these. Support strategic modeling, that's what we've really been talking about here. The question is not what happens if I do X. The question is, I have an entire alphabet of possibilities here, not just X. Which one of these, or which combination of these, would be the thing that gets me closest to what everybody I'm working with thinks is a desirable outcome, and does so affordably, and does so on a time frame that I can actually manage, that does so without massive political risk? Yeah, we could do a lot for transportation if we decide to do heavy cordon pricing and really jack up the parking costs and tax the heck out of people who own cars. And politically, that's probably not a possible, feasible thing to do. So we're going to have to go back to plans B, C, or D. And in fact, those are three of my scenarios: B, C, D, E, F, G, and so on down the alphabet. That's the strategic modeling approach. Once we've figured out the strategy, we can turn back to our activity-based model and other sources. Whoops. Let me try. We just lost our public screen here. It'll be back, I'm hoping, in a second. Again, sorry about that. You know. Let me see here. Shaky connector, don't touch. All right. So, anyway, I want to go back to that previous slide. Modular. VisionEval, and again, we'll talk about this in technical detail this afternoon when we go through the multimodal module, for those of you who really want to roll up your sleeves and be computer programmers. For those of you who don't, what I'm telling you and a few of the things we'll say later on are probably all you need to know about this. VisionEval is made of different pieces, and my next slide will go through piece, and we'll talk about that. The modularity of this thing means that it's relatively easy to add new stuff. So you mentioned ITHM before. One of the things we're looking at is to say, ITHM does all of these cool, sketchy calculations that use a lot of inputs that you can get out of VisionEval scenarios. And so wouldn't it be cool if we could tack on all of those health indicators as performance metrics to what comes out of VisionEval? Ta-da, we could build a module that contains ITHM or ITHM-like stuff and make it a piece of VisionEval for estimating this stuff. Other important piece that, again, we'll talk, this matters more to the folks who are developing stuff when we do it this afternoon. We'll go into this in some depth. Open science approach. We want to be able to show people what's happening inside of the model, because for all of the things I've been mentioning as example phenomena that we'd like to capture, we can't really even begin to come up with quantitative estimates of what goes on in these phenomena unless we make assumptions about what the future might be. How susceptible are certain households going to be to doing shared mobility stuff? We don't know. We haven't seen enough of it yet. It gets worse when we start talking about the flying over drones that are going to drop the goods on my front door. How much of an effect is that going to have on whether people go shopping or not? You know, that's a good question. I mean, I can make guesses about it, but I want to know. And so one of the aspects of the open science approach is everything about VisionEval is documented. You can open it up. There is actual written words. There is the code itself available. You can look and see what is it assuming, what is it done. There are things that you can adjust. We started from a certain base of data. There are calibration things that we go through, some of which we'll allude to as we work on the demonstrations this morning. Calibrations that say, how do we relate what we've seen in the world, that we've measured in data, to things that come out of the model? That's something that we want to know about. We'd like to be able to reproduce it. We'd like to be able to do it again, perhaps, with other data. And so those are all factors that we've considered from the beginning of the system and we've built into it. So those are all possible. Some of them require some work. You know, I don't want to pretend that you can do all of this just by, oh, you know, VisionEval, great, flip a switch and there's my answer. You know, it's still not that easy. I mean, you're still going to have to do thinking. You're still going to have to do data preparation. You're still going to have to do work. But what you will get as a reward for that is something that is in fact more responsive to the kinds of planning questions that we're all really grappling with at this point. Implicit in that, of course, is the next bullet, customizable. The built-in error checking piece, because this is modular, because there are pieces that come from all over, we'd like to double check that the modules actually are conveying appropriate information. I mean, one of the projects I worked on years ago required reconciling two regional models, and it turns out they had sliced up the weekday and weekend stuff in entirely different ways. They had different peak periods, different full day estimates of what was going on. And the data, even though it looked like they were generating the same numbers, was at a really fundamental level incommensurate. And so what we've tried to do with this is to make sure that all the data that goes into the model is carefully documented, the outputs are documented, and this is most important for people who are developing new models. But it's also important for people who are trying to interpret the results, because there are implicit assumptions about how the world works that are encoded into the structures of data that we've put into this. And you need to be aware of those, because you can, if you're not, it becomes possible to make wrong conclusions about what the model is actually telling you. And so the bottom line on all of this is there's a lot of smartness that went into building this, and we've tried to keep everything turned inside out enough that you can understand that and reckon with it and make your own decisions about, is this appropriate for the kinds of questions I want to ask? So the schematic on this, and we'll go through this in some detail later, define households, land use, transportation system. There's a whole sequence of things that we'll do with some iteration between these steps so that, as we start congesting the roads, we can feed that back and change, just how much people are going to do with this stuff. I won't stay with that. I've mentioned the modularity. It is a collection of modules. We've really tried to organize the system physically, like Lego blocks. So we have standard models like RSPM or the Rapid Policy Analysis Tool, RPAT, that are canned collections of modules that will work. Because we've got the documentation, of course, and because we understand what goes in and what comes out, not just of the whole model system, but each of these modules, we can plug and play. So if there are pieces of RSPM, for example, that you're really not interested in, you could drop those out of the model. If there's cool new stuff like the multimodal module that Liming put together with help, you can put that in and actually have that be a piece of it. And as long as you play by the rules, which are pretty well documented, what comes out will still be useful. So that's part of that. I'm not even going to look at this too much, but other than to say we have this modularized at several levels. We have modules, we have packages. This is something we will come back to technically this afternoon because it's more important for developers. We'll see a little piece of that when we install it. And I think this is the point at which I hand it over to Tara. And so now I can tap my watch and watch her for like talking too long, and we'll see if we can get out of here.
Yeah, all right. I'm going to give you a little example. So you've kind of got this gee whiz idea. How do we actually use it? So we've used it for quite some time in Oregon, and it ends up that it's part of our toolkit now, but it's a new part that we didn't have before. And part of that is because of the uncertainties of the future. Before, linear, we were growing, VMT, new drivers, kind of just linear to the future, but now we have all these new modes and stuff, and so you can't just like extend the future, you have to think of all the interacting things. So we want to do that in a strategic way where we may not know a lot of the things. Drones, can we throw in something into the model about this new technology in, $20,000 of effort rather than $1 million and a lot more work in an activity-based model. So we've got this new conversation started, which is strategic, and it's the fact that we don't have one future, we actually have a lot. And so now I can answer when somebody asks me a question like, well, what if this? I can't say, well, the model assumes this. I can say, I can run that because I can run thousands of runs, and then we don't have to all agree. I can run a bunch of them, and then we can say, well, if your future happens, this is going to happen. If the other futures happen, this happens. So it becomes a different conversation and more strategic and helps us to just think better. So that's been helpful for us. And we still have our tactical models, our urban travel models, and they will help us once we say, hey, this is the share of money that goes to transit. How best do we do transit? And it'll figure out more tightening down the economics and things like that. It just has one economic feature, not many. And given that, it'll fine tune things. And we need that, right? We continue to need that. But now we have this new piece in there. And then we can go down and do particular projects. And increasingly, we're monitoring with big data or something like that. So anyway, new piece in our toolkit. And so what I'm going to do right here is to say you're a technical tool person. You got your technical hat on. You're over on this right side, the technical tool track. But you're only here because you're supporting a conversation that's on the planning side. The planners are going to go and talk with tax, with the public, probably more with tax of, what is this conversation? What do we want? What are our goals? Kind of a regional transportation. We tend to think of this as either an assessment of your plans, like after you've done your regional transportation plan, or a precursor to what are your goals and what do you want out of this at the beginning of that plan. Anyway, you have this conversation, and that's the most important thing. The tools are just supporting that. So how do they support that? The first thing is they'll have a kickoff and do some policies and outcomes, both what levers do they want to move and what kind of goals do they have. And over on our side, we'll get prepared with, training like this, 101. We'll go to look at the adopted plans, the regional transportation plans. That'll become our sort of reference scenario that everything will pivot off of. Then we'll start prepping for inputs that we're going to need from the planning folks. So we'll look at the land use. So we use something called place types to help us figure out what population, employment, and so forth. A lot of this we draw from our travel demand models that are already there. And we'll look at the transport inputs. And there's some new things there on vehicles and fuels and stuff, some of which may be sort of defaults that we have at the statewide level that we can provide to local areas and so forth. Some will be, transit assumptions and things like that that we'll want to get to the local. So then we go and we talk to them and we say, okay, here's a reference, starting point. Is this really what your future looks like from your RTP? And we'll let them tweak on that. And what happens is when you go into those conversations, they say, this is what we're funded for, but what if fuel price doubles? What if? There's all these what ifs, and you write those down too, because those are the tests that we're going to do that pivot off that reference scenario. So this is an important conversation point for us to not only get validation of that reference, but start to think about what kind of sensitivity tests we might do. So then we go and we sort of validate the model, and we run that reference scenario, and we also run a bunch of sensitivity tests. And a lot of times people don't necessarily know what will move the needle or what they don't want to sign up. There's a lot of conversations you can have to get that right number. But we're not talking about a right number at this point. We're saying, what if you do a lever? What's a low, medium, and high? If you double transit, there's a lot of this doubling. Or what if fuel price doubles? And so you can do that easily. We don't have to code in a whole network of transit with stops that reflect a doubling of frequency, which would be a lot of effort. We just say double the transit, and then our access to transit maybe gets better. Which is more of a zonal information. So anyway, that's the kind of thing we'll do there. So we get both a reference and then a bunch of pivot points off that. So we go back to them and share that and then go, oh, what moves the needle towards our goal is this or that. That's the most important thing. Gosh, that pricing thing moves just about everything, Anyway, so those are, then you can look at not just your reference, but the multiple things. Then we start to say, well, what are your criteria? We sort of start to bound that problem that they say, we don't want congestion to get that much worse than today, but we really want to try to reach and maximize our greenhouse gas reduction, but we don't want to do it at the expense of household costs. So you start to get these sort of constraints on all those scenarios we ran to look at some key paths for the future. And they really set what those criteria are to control that space. So that's the other pace. And then we would start to constrain that and say, here's the kind of combinations that seem to get you to that goal given those constraints. Let's get some local agreement on that, and then let's link it to your plans. So that's kind of how we use the tool. So then I'll go through here. This is a little bit of what that conversation looks like. So this is something where we went to, I think it's Rogue Valley. We've also done this most recently in Albany, and Central Lane did a similar thing. So this is at an MPO. We call this a strategic assessment. And we start out and we say, here's the kind of inputs we have. Some of those you can't control, like those regional things, like the demographics are going to happen. You kind of have a best future, but what if they are different? So you can change some of those things. Then there's, on the other end, our collaborative actions that maybe a local can't do a whole lot about because the vehicles and fuels are more like federal CAFE standards or state-led policies on ZEV, zero-emission vehicles, low-carbon fuel standards. Pricing sometimes might be more, state gas taxes or going to the Origo VMT fee kind of approach. But in the middle is where they can play. So that's what we say, you can change your community design, and all those kind of things with modes and what kind of housing you allow to be built. And then also there's a bunch of programs and things that you can do, whether that's ITS programs, operations on the roadways, or car sharing, or so forth. So anyway, that's what they can do. And then we go in and rerun this. So this is where we actually said the goal here was partly with the greenhouse gas,
trying to reach a target that we have for each of the MPOs, which is voluntary. So their adopted plans got them to about here, a couple percent, but they really wanted to get to 21%. So we said, let's push it, all these things a little bit harder. Let's take this and push it at 2 levels. Let's take the marketing incentives and each of those at 1 level. So these were just what we call like unidimensional or one-offs, where we just tried one thing. You had a reference plan and we changed one thing. None of those got up to the target of 21, but you could see they're all moving in the right direction, and if we have combinations, certainly we'll get there, which we did. So when we got to those key paths I talked to about, you have their current reference, the adopted plans in orange, the key paths are in the blue, and we are now measuring for a bunch of different things, not just the greenhouse gas, but these key paths were getting to their main goal. Now they had some choices. Which of that flavor did they want to work out? So what mattered to them in terms of VMT, walk trips, travel costs, air quality, and road congestion. And then another trick that comes out of this when we run lots and lots of scenarios is we can start to have like an interactive viewer. So this is a web-based interactive viewer where we have thousands of scenarios that we've actually run behind the curtain to understand the trade-offs and resilience. So the top level with those dials there is the inputs. So people can say, I'd like to have a high-level community design, but I don't want to be priced. So they could start to pick and choose the policies that they want, and over on the right are even some uncertainties that they can choose. And then down at the bottom, it shows the distribution of all the scenarios that met that criteria. You know, where does it fit on the greenhouse gas or VMT per capita and all those kind of things. The other neat trick is you can go to the outcomes and say, well, I want the ones that have the high bike share. And then it goes up there and tells you which combinations get you to that. So anyway, the interactive tool has been really helpful and one of the key things I think of value.
We'll demonstrate that a little later on.
Right.
You'll actually get to see it be interactive so you get a feel for what happens. And this is out-of-the-box stuff, and we'll explain that as well.
And there's lots of versions of this. Basically, it's resting on the thousands of scenarios we ran and different ways to visualize it. Peter.
One of the considerations from both a climate and a congestion perspective is where in time the changes occur. So particularly with climate, reducing emissions now matters more than reducing emissions the same amount 10 years from now.
Uh-huh.
Does the model allow you to change the timing of the scenarios so that you can change the emission profile over a short period of time?
Well, I know at the state level we actually run every 5-year period, so we get from 1990 all the way to 2050. So we actually get all those, and we can do a cumulative kind of thing, right? Because greenhouse gas is cumulative. When we've done it for metropolitan regions, they tend to look at that 1 year. So it's able to do this stuff in between. If I'm answering your question right, it seems like you had another thought.
Yeah, and I mean, I would say there are two angles on that to answer the question. And I think what you're asking is sort of the delayed effect. So if we implement policies this year, we're not actually going to see the effects of that, in any significant amount, or the effects will be different as you sort of cumulatively add it up over 5 years, 10 years, and so on. And so if we so I guess the question is, if we set a future year where we're comparing these different scenarios of, say, 2050, and we want to look at the results, some of the effects that we're going to be looking at will have an effect by, actually, let me make it closer, 2025. Some things we could do might have effects by 2025. Other ones we're not going to see the results until later on. You can certainly set arbitrary future years in VisionEval. So you can run all of your scenarios against a particular year, a particular 10 years beyond that. In terms of the dynamics within the model, personally, I don't know enough about what the calculations were, and I mean, I could probably glance in the direction of Brian and see if you've got any indications on that. But I would say, we can kind of look at different future horizons and then run the scenarios at different cases.
And I'm actually asking a slightly different
question,
and that is, if we were to implement a commute trip reduction program in 2021 as opposed to in 2026,
Mm-hmm.
what are the implications of that for VMT, motor, greenhouse gas emissions at various points in time? Which strategies provide what level of benefit over what time horizons? Because going back to our original conversation, one of the things you said originally, you have a limited amount of political capital. How do we spend our political capital in ways that produce the greatest benefits over the shortest period of time? That's what I'm interested in. curious as to whether or not the model allowed you to look at varying the time of implementation in a way that
It is I don't know, Brian probably has some other thoughts, but I think it's a level of detail.
You can model, by year, and then you can add up those effects over time. Say you're interested in cumulative greenhouse gas emissions. So you could certainly do that. So I think what Jeremy was getting at is that it's not like these time-dependent integrated transportation land use models where if you change land use today, then that affects the transportation decisions the next year, which then affect how land use changes the subsequent year. So if you have a program and you say, here's the schedule of implementation over the years, and you run then the model for all of those years, you can then look at the cumulative effect over all those years. And if you implement it on a different schedule, you can see the cumulative effect of that schedule.
So the onus is on you as the user to lay out a plan, and then it will implement it, but it's sort of aspirational. If this plan would roll out in this way, I can model it and see all those feedbacks and so forth. But it's on you to kind of roll out that plan, because this is not a how, this is more a what if. Okay, so I think that might be getting us to the next spot, and we're probably much more than 30.
All right, I'm going to make the next part quick. Famous last words. Last words? What are last words? This is me, right? Okay, so what we're going to do next, we're going to step away from the presentation part, and we're going to look at what you do to get VisionEval, and we'll start inching into the physical setup of this stuff. And in my mind, we're going to do this in two pieces. I'll do a bite now to show you how to install it, what you get when you install it, how you run it. Then we're going to come back and we're going to talk a lot about actually running it, doing the concepts, looking at what comes out of it, trying to figure out how to get your mind around the kind of problems that you can express in VisionEval terms and then get useful information about it. And we will come back at the end after we've done that and say, let's look again at what you actually got, remind you of this a second time, if there's time to do that. If there's not, we can, if you're really interested, we can hang out at lunch. But we'll give you enough here to go with this. So what I'm going to do is, let's escape from this for a minute, and we'll put that down. And we will go back out to, let's see, let's go here. No, actually, let's go to the website first. Concepts there. So the home base for all things VisionEval is a website called visioneval.org. When you go there, you see a bunch of stuff here. Let's see if we can get the taskbar to decide to go away so you can see all of it, because there is actually, all right, I'm just going to taskbar settings. I'm just going to make it, I'm going to go away from the auto hide and just have it be there, because that will let you see the whole thing. Go away again. VisionEval. So home space, we've got information for users, information for developers. Developer stuff we'll talk about in depth this afternoon. Today we're talking users. There is a wiki. So if you punch that up, I already had it punched up, but there it is. Getting started, lots of explanations. We'll go over a lot of what you find in the getting started in a minute here. And then, of course, if you really want to get into it, you can go and look at the code. We'll come back to that later this afternoon.
And
so
this sidebar, mention that.
Yeah, the sidebar, home, download is the magic thing. Information for users. We've got a bunch of case studies and various places where people have used this, so you can see examples. We'll be adding more to that over time. Information for developers. This gets us into the getting started, the wikis, the GitHub stuff where all the code and the data live. About VisionEval is really, kind of, we're doing that.
And the sidebar in the wiki as well, that's a really...
Yeah. Oh, the sidebar of the wiki. Right.
Yeah.
Yep. So in addition to like the homepage here with links embedded in it, there is actually a sort of analytic table of contents on the right that tells you other things you can get. So you can get tutorials for each of the two main models, RPAD and RSPM.
We sent you to a lot of these things in the pre-work.
Yeah. So is that our presentation slides? Is that something else? No. Okay. So
from the training and...
okay. Right. Yeah, we got all sorts of stuff. So you can nose around on that. We're in the process of trying to organize this better so that it's more clearly designed for like new users, intermediate users, advanced users, and developers, but we'll get to that. So the magic thing that you're most interested in if you're getting VisionEval is to hit this download tab. You get here, it says get VisionEval here. And if you click that, it starts to do a download of a file which at the present time is 585 megabytes, which is, even by the standards of modern software, enormous. And the reason that it's enormous is that it includes literally everything you need to run the model, except for one thing, which is the R statistical environment. R is an open source platform for doing statistical analysis. You can work with it interactively. I discovered R about 15 years ago. That's actually how I met Brian originally. It's because he was into R, I was into R. We were doing all of this stuff actually before he even developed GreenStep. I think you were hard at work on it when we first met years ago. But R is very cool. And so you need two pieces for VisionEval, one of which is this installer and the other one of which is R. If you punch the OK, it'll download it. I've already done that so we could see that. The piece that you actually need is R, and I should have shown you this because it will help you get that. So R comes in multiple versions. The place you get R is at, and I'm going to pick this one because it's there, cran.r project. And you actually don't need to know this because you can install VisionEval just from the zip file, and when you double-click the batch file to start it up, if you do not have the right version of R on your system, it will open your browser and take you to the page where you can download the right version of R. So, you know, what I'm telling you here is slightly optional, and I'm looking at our website, and Dan, you're out on the phone there, and if you're still there paying attention, we need to have a link to R as well as, and maybe we do, I just didn't see it right off the bat. But anyway, cran.rproject.org, download and install R. Download R for Windows. It'll actually run on any of these systems if you can get the whole thing out there. We don't have an installer for Mac and Linux at this point, but if you want to do it on Mac and Linux, I can tell you how, and we can set you up with an installer pretty quickly. We do them for Windows because that's, 98% of people in public agencies are working with that, so that's the part that we put the energy on. So what you can do here is you go and install base R, you hit base R. This is the page that VisionEval will take you to itself if you don't have it, and you download R for Windows. Now, the other piece of this that's really important to know, and you think, oh man, I'm working for a public agency, they don't let me install anything on my computer because they're desperately terrified that I will install Solitaire and Minesweeper and never do another hour of work as long as they live. But that's not the case. We're good, and we install useful stuff. Productivity enhancement tools. R can be installed on a system without administrator permissions. It installs, as long as you can run a program on the computer, you can install R. It will give you a little warning saying, oh, you're not an administrator and therefore you won't have access to all the R features. Trust me, all the R features that matter, including the ability to run VisionEval, you can do if you're not an administrator, and everybody will be happy. VisionEval itself, once you've got R in place without administrator permissions, will just run. And so we'll get to that. So the key piece is, when you get done with all of this, I will show you, you get a download that includes the installer. I've got two versions here. If we drag the window out, you can see that this is in fact the full 500 and something megabytes of stuff. And we unzip this. And I'm not going to do it because it takes 10 minutes to unzip. 590 megabytes is a lot of megabytes, and when you unzip them, it becomes a gigabyte, and then it's pretty big. So
And we have to shrink that over time.
Yeah, we're working on that. I mean, and the catch there is, and so let me talk a little bit, side piece of this. Like VisionEval itself, R is a modular system. And one of the beauties of R is anything you want to do, somebody else has already figured out how to do, except for the planning stuff. That's what we're working on. And you can download these packages and install them. And so what we've done as we develop VisionEval is to make use of everybody else's cool work. Statistical model estimation, no problem. We've got a package for that. Working out how to manage files, no problem. We've got a package for that. And so we used all of those packages, and there's a lot of them. And the catch is that some of those packages we used have used other people's packages, and you put one of them into VisionEval, and all of a sudden you've roped in another 65 megabytes of stuff. And so we're working on sorting that out because we are intent as developers to try and take this down to something that's just a little bit more manageable for people, and we will get there. I will point out, however, that about 200 of those 600 megabytes, and I'll round up generously here, are data. And so among the things that come along with VisionEval is an entire download of the complete National Household Transportation Survey of 2001. And what comes down with it is a bunch of information about, fleet mixes and fuel stuff and all the data that we use to calibrate the models in the first place. So all of that's there and lives in this user space. And again, for people who are end users, some of that is optional. Probably people who are end users do not need the original 2001 NHTS. They need some subset or slice or preprocessed version of it. So we're thinking about that. Development stuff. So when you unzip it, what you see is something that looks like this. There are a series of files here and some subfolders, and I'll take you on a little tour of what you need to know about those in a second. The magic one that you want, and it says it this prominently in the download instructions, is this VisionEval.bat, this guy. It's a batch file, Windows thing. You double click it and it does stuff. So we'll double click it, donk donk. And what it does is it finds the R, and so of course if it doesn't find R on your system, this is the point where it does what I said it did, which is open your web browser, find the right version of R, and take you there so you can download it. So you download R, you install it, and you click the batch file again. And when it gets all over and done, R is running, and you have VisionEval in place. Now, you could just start from right here and start doing things. If you're comfortable with R, that's okay, you can do that. If you're not comfortable with R, you will notice, actually, and I'll highlight the line up here, type Q parentheses to quit R. Very important, because if you find yourself stuck in a program like this and you've never worked with it before, the first thing you want to know is, how the heck do I get out of here? Go away, leave me alone. And so the way you get it to go away and leave you alone is you type Q, 2 parentheses. It will ask you save workspace image, and you say, I have no idea. The right answer here could be yes. We're going to say no. It doesn't actually matter. If you say yes, it will create one more little magic file for you that keeps track of everything you did, and that file will say, oh look, they started R and they quit. It's like, all right, that's cool. Later on, if you've done calculations working with R, this is one of the beauties of it being interactive, is it'll save all your work. And it's like, how did I do that model estimation? Oh, let me scroll back through the history and figure it out. And oh, look, there's the whole estimated model. I've got the data already. I don't even need to rerun it because the data is still there. That's saving the workspace. Side issue, probably not relevant for VisionEval. Once we've done that, every time we start VisionEval, there are two ways to actually get it to go at this point. I can click the batch file again. The first time you run it, if you were looking closely, it actually created a couple of new files. It figures out, based on where you put VisionEval, because you have to unzip this file into a new directory, it figures out where that is, it locates all its necessary pieces, and it leaves little track records behind so that it will happen again even more quickly. You'll notice it was pretty fast. I mean, we got to R like bingo. It's not a slow thing, but it puts pieces in place. All right, so running it again, we'll click the batch file. The other thing we can do is use a program called RStudio, which a lot of people find a little easier to make their way around than the standard R graphic user interface. It just comes packed with R. We'll go back to the browser for a minute. All of this will be listed in various handouts that you will get, or screens that you can take pictures of. RStudio is another open source, well, actually free, we'll put it that way. I'm not sure, some pieces of it are open source, some are not. You can download RStudio onto your computer, and it's basically just a wrapper around R, and it gives you a way of understanding a little bit more easily what's happening with it. So we're not going to stick with that for too long. What I am going to do, though, is open RStudio, whoops, wrong window. That's the one. I am going to open RStudio to do the rest of this stuff, just because it'll show us a little bit more. To do that, there's a file that comes with VisionEval called VisionEval.rproj, short for R project. You can double click that one. Don't do this the first time. The first time you should always hit the bash file. The second time you can hit VisionEval.rproj, and this will load up RStudio, which I have conveniently installed. And we get a list. Now, if you look closely, the left side looks just like the screen I showed you before. See, there's the magic message that I was telling you about how to quit R. You type Q with the parentheses, which in RStudio doesn't actually quit. For RStudio, it's more like your good old Windows program. You go File, and you quit. And you're out of there, or you can just close the window. This gives us our directory. This is the same set of stuff that we were looking at in the File Explorer before, and it also shows you the data objects that are currently loaded. And you'll notice that there are a few things up here that RStudio has loaded into it. These are functions, VE GUI, VE RPAT, VE RSPM. The GUI gives you a simple way of manipulating the models, and we'll talk about that in a second. The models themselves, RPAT and RSPM, can be run from functions. I'm going to go back out to the File Explorer just to say those live out in this folder called models. So you remember, we looked at the VisionEval base thing, we found the batch file, that sets everything up. We can start it from the R project to get to RStudio. And we can look at and we have these directories. The VE Live, which is the giant source of everything, has all of the R packages and everything else in it. We'll come back and see the VE Scenario Viewer a little bit later on. I won't talk about it now, but after Tara's shown you what we do with the scenario stuff, we'll come back and look at the Scenario Viewer that's stock with VisionEval. The GUI is out here. I mentioned the function. We'll come back and look at the GUI in a second. And then the models are down in this directory called models. Now, a model in the world of VisionEval is a series of modules that are strung together. There's a descriptor file for each one, and there's a set of data. So we have sample data to go with the models themselves for each of these. VE RPAT, VisionEval Rapid Policy Analysis Tool, RPAT. We'll talk a little bit about the distinction between these later on. When we talk VisionEval, mostly we're talking about the other main model, this one called VE RSPM, the Regional Strategic Planning Model. Okay. Yeah, acronyms, they're hard. And we have VE State, which is a re-implementation of the original green step that Brian's been hard at work at for the last year and a half, because that does things that are a little different than some of these other models. The two scenario versions here we'll talk about later. This is a convenient way to set up scenarios. You remember we said we can do hundreds of scenarios. Usually these involve combinations of a much smaller set of future policy innovations. I'm going to ramp up transit, I'm going to raise certain parking costs, I'm going to do different estimates for different things. We can set up the basic possibilities and then just say, okay, VisionEval, go ahead and do models that are permutations of all of those basic inputs. And so I've got 3 options of transit and 3 options of pricing and 3 options of something else. And it will do 3 times 3 times 3, 9, build up all the models and run them for you. And yes, after you get into the hundreds of scenarios, this does end up taking a little bit of time. So,
Storage.
Yeah, I mean, hey, we'll just do it for you. And then you come back at the end and you look at what you got, and we'll see what you got at the end. Inside of the model itself, we've got a bunch of pieces. The magic ones that you're going to end up digging into to set up scenarios would be these inputs and definitions. And then the model itself is contained in this thing called runmodel.r. I think I can open that with. I should have set up the open with. Come on, guy. Yeah, more apps. I like this one, which will enable us to see it. The runmodel.r has some R instructions. Typically, you won't ever actually have to go into this unless you're really working on scenarios and whatnot. It's basically the control file that says, here's what we're going to do. And it tells us to run a bunch of modules. They will sort out their data connections to each other and get you the results. The other piece, though, is the inputs. Wow, long list of CSV files. That looks intimidating. It is. And we're going to unpack that for you and explain some of this later. And the GUI helps you with that, and we'll get back to that in a moment.
And your handout, that one just lists all those, and it has this nice category things.
And you remember the sidebar on the wiki, on the website. You can go out there and it will explain to you in meticulous detail what's in those files, what the data is that you have to come up with. Some of these you can borrow from the sample implementations here because it's sort of stock data and mostly doesn't change, but mostly you're going to want to visit all those files for your local area. Okay, so that's a brief tour of what's in the models. I think the simplest way then to start looking at this is, what do I have to do to run the model? And so actually, let me go back into VerPat for a minute. You'll notice that the run model script has this .r at the end of it. That says it's an R script. That means that if you open up R or RStudio, you can simply point it to that script and say, get me the stuff that's inside of that. So let's do that. Actually, we're going to run RPAT and just see what happens. How am I doing for time there, Tara? Give me another 10 minutes on this, and I think we'll be good. So let me think for a moment. Go back up to the top. I'm going to do this with RStudio just because I said I would. We'll bring that up. And if you get into RStudio or R and it's got this welcome to VisionEval message, you're ready to go. So there are 2 ways we can do this. We can do this by hand, which would entail setting the working directory to model slash, well, actually I think I need a /verpat. And then I go source run model.r. And this is the hard manual way to do it, and then the model starts. And I guess I'll just put go on that. We do have this convenience function that I pointed out up in the upper end, so my other option for this, I could escape from that. Well, actually, let's not. Do I want to back off of this? Yeah. You can also do this if you're just running the sample model. So I could run verpat, 2 parentheses, says function, do this thing for me, and it goes and it does it. So these are canned commands. I mean, there's nothing here to actually learn other than I'm going to type these magic things. I tell it what directory has my model, and I tell it to source the run model command. So I'm going to do that, and you're actually going to see it go. And it's starting. Okay. One directory deleted, that's because I had run it before, and so now it's running it again, and it threw away the previous output. And you should be aware of that, because if you've made changes and you want to try it again, but you want to save your old output, you're always best off copying the directory someplace else and running it again. The magic of a VisionEval model is the scenario plus the model code is a unit that lives in a directory. And so if you wanted to take one of these sample models and make your own, the first thing you're going to do is take that verpat directory and you're going to copy it somewhere else. So we'll just let that go for a minute. So just to point out specifically what that would mean, you'd go down into models, you would take, I'm sorry, my mouse, I don't have quite enough room for my mouse here. I copy and then I paste. And this will take a little bit of a while, but not too bad. And now I have verpat copy. This is mine, and I can go down in there and change all of my data and do whatever I want. Okay? So the scenario builder will do that for you. While we're doing that, we're just going to let that go for a while so you can get a sense of how long it takes for one verpat scenario to run. And I think it's about 10 minutes maybe, something like that. What we can do is go back out here, and we're going to start RStudio all over again. I go back out here, I go up to my stuff, I'm going to go back down to the R project file, start one more time. This will start another instance of RStudio. So you want to be cautious about this. It depends on how many cores you've got on your computer, because you can, if you run a lot of these things simultaneously, you will bring it to your knees. What we're going to do from here is we're just going to leap straight to the VE-GUI function. And I would say this is the instructions for doing this are listed out, but I'm not going to take you through that manually. The convenience function here is better, and since the whole GUI is about convenience, we're going to do that. VE-GUI actually starts a whole web server on your computer and then points your browser at it. And what you get is this. And it looks like you go, oh, how interesting. What do I do with this? Well, what you do is you select scenario run script, and this opens up, we're down here in the models folder. Remember we were in the models folder before and we found verpat and we looked at all the subdirectories and everything else. The GUI is just helping you find this more easily. And so if we wanted to run verpat, we could go down into verpat, there's the run model script, and we can select that. And this will open it up, look at the script, see, and it's thinking about it. It's going to think a little longer because this is not a high-powered laptop and we've already got it running RPAT in the background. So, things may be just a tad slower than they would be otherwise. So it tells us what the run script is and tells us what the modules are. You remember I said if we looked at the script, we zoomed past this, there was a list of here are the modules in the model. It tells us what those are, and it lets us look at a few things with that. And what it's going to run. So some of these modules are going to get run for all years, and the setup for the scenarios includes a base year and some future year, possibly more than one. Actually, does it do possibly more than one? I think I've only seen it with a base year and a future year, so I'm kind of looking out there at the folks who have worked with it for a while. Anyway, moot point. In the settings file, we can take a look at the run parameters. I zoomed past a subdirectory called defs, and you'll see it again here. Donk there. The defs directory has parameters that tell us what year we're running for. So this one is going to run for base year 2005 and future year 2035. And it tells us where it's going to put the output. We'll come back to that in a second. The model parameters here are things that we might want to change that have, we'll discuss some of these, and they're also heavily documented about growth rates, gas tax rates, stuff that goes on like that, that are going to be applying to all of the scenarios. The inputs are where the action is. I'm sorry, not the run, inputs. You remember I said we had a pile of CSV files. Here they all are again. The virtue of the GUI is that you can go and visit each of those and say, I wonder what's in here. oh look, I've got parameters for, in this particular place type elasticities. How much does stuff change in the different place types for VMTs, vehicle trips, and stuff like that. You can actually go in and edit the files here. So if you want to play around with some of the base scenarios, that's certainly a possibility. And you can feel free to do that because you downloaded the 600 megabyte zip file. If you decide to play with the samples and do something to it that stops working or it goes haywire, you can just unzip it again and it will replace everything with the original versions. If you are doing new stuff that you want to save and not have it be overwritten by a future version, you should put it in a different directory. So you just copy the directory and go with it. So again, we'll take a tour of these later on. And eventually we get to run this and it'll show you what's going on. If I push run model, what I get back to is VE GUI's version of what we see happening over in RStudio at this point. Let's see, I don't need that one anymore, I don't think. This is the one where the action is. We're still cranking away, chugging out the stuff. One other piece that is potentially useful to know here is, sorry, wrong folder. This one. In my models directory, I'm running the Verpat model. There's Verpat. I have log files for all of my runs here. And so today is the 20th at 13:08. That's because I'm on Eastern time on this computer. I forgot to change its time zone, so it's 3 hours later. All of the stuff that's going by on the screen, plus some additional debugging information, lands in this log file. So when you have problems with this and it doesn't do what you expect, you can look in the log file. Usually it's got more information about what went wrong. At the very least, it gives you something to call me up about and say, I was trying to use VisionEval and it didn't work. What do I do now? I answer questions like that, or I get Dan to answer them for me. Hi, Dan. And we'll go from there. So the log file is the other key piece. Let me think about this for a minute. Is there anything else I probably need to say at this point? We may have done enough for now. So we're just going to let that continue running away. I'm going to return to the stuff in the slideshow and let Sarah continue. I guess that's the next step. Or do you?
Yeah, I mean, I guess there is a CSV where.
Oh yeah. So let me show that. So for example, let's say that we have a model that we've run. I'm going to start up. Let me see, I think I've got a second RStudio going here. Oh, that's the one that's running. I'm going to hit the little stop sign there. Stop that. Clear. Oops. Now, control that. There we go. So the other piece is, let's suppose that I have a model. Let me get my working directory here just to remind myself where I am. Okay, set working directory in this case, and this is navigating around. Some of this you may not have to do, but models VRSPM. So for example, in this file here, we've got a bunch of stuff. I've run RSPM before. One of the things that you get as output from this is a series of R data objects, which in themselves are not transparent in the sense that you're not, unless you're an R maven, are not necessarily going to know what to do with them. We do have a convenience function called VE export, which if it's sitting in a directory that happens to have a model run, will simply turn around and extract all the data, and I'll show you what comes out. You just say VE export. It takes the R data structures and turns them into comma-separated value files, CSV files. And the beauty of a CSV file is you can load it into Excel, you can load it into Tableau, you can load it into Microsoft Access, and you can do all sorts of cool things with it.
So it's all in that data store, and now you're just exporting it.
Yeah, so let's go back to the directory there just to show you what's up with, let's see, which one do I want to be in? Let's go there. So we're in models, we're in VERSPM. The data store is the one that contains a bunch of these R objects, and if we look out here, there's an A zone thing, and there are all of the R data objects, RDAs. The data store itself requires you to do a lot of, I mean, you can get all the information out of there, it's there. It just requires a little more work. What VE export does is it creates this folder called output. Inside that folder called output is a much simpler set of CSV files. So everything that's out in the data store that had anything to do with the A zone and B zone structure. And we'll talk about A zones and B zones. This is a big piece of what we're going to be discussing. Let's look at the household one. So if I double click it, it's going to open up an Excel, because that's what mine does with CSV files, my computer. And I shouldn't have picked that one. because it's huge. But, all right, yes, 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 I accept the license agreement. That's because I'm a new user on this computer. Stop already. No, don't send optional data. Let me alone. There's our CSV file. So this goes and tells us all, by zone, all of the stuff we want to know about the demographics that were going into this. What are the households? Who are the people in them? How many do we have of each one? And again, as there's a lot of documentation on this. Some of the stuff that shows up as quote-unquote outputs are in fact inputs, but that's just so that you can navigate and figure what goes on. But all of the columns of new stuff that was calculated by VisionEval shows up here. So I think that was the other piece I was going to show. We're going to talk more about the actual contents of this, and then we can come back and revisit this. Any questions that somebody has? I mean, even if it's just a sort of vague, it seems to me from what you said, I'd like to do something like this. Is there a way to do that?
I have a basic question about
Sure.
what's the difference. Could you talk about how RPAT and RSPM are different?
Yeah, the principal difference is geography, in that RPAT works on kind of larger zones of stuff. I mean, it was originally developed to do land use processing, so I think it evaluates a series of, let's just say, transportation effects from land use inputs that are not typically in RSPM.
So like the region is one geography, except for it has this layer by place type. So you can say my mixed use area of this one metropolitan area, or my rural area of this one metropolitan area. So that's the geography of it, whereas the RSPM is more of a district focused. It's larger than most TASs, more like a census block group. That's the way it was estimated. So part of that, then there's some other things in RPAT, like it pivots off 1 year, so a lot of things are relative. RSPM is sort of, here's your year, and everything is sort of self-contained in that year. So there's a couple nuances like that. We're trying to get them all on the RSPM approach, but at this point, there's still some diversity.
Right.
And then the state is just the ability to have places, multiple metropolitan areas, and then maybe some towns and rural areas thrown in. So it's got like this multiple geography combination thing.
So presumably we can select for subsets within the region, so City of Portland, for example.
Mm-hmm.
Right.
Yeah, I mean, you could set up a model for the city of Portland, you could set up a model for the larger region, and then just identify the city of Portland within that and say, okay, we have these other things going on out there. And I mean, I presume that you could actually do scenarios where you were varying certain, you had sort of like stock things that you were curious about in Portland, and you wanted to see what were the effects if somebody in one of these other areas does something. You could play out scenarios with that, sort of like, how much at risk are we for the silly decisions made by our neighbors, for example.
Yeah, we hesitate in Oregon to do it at anything below a sort of metropolitan area. We could do a county, but if we are at a sketch level, right? So it's strategic. So we are looking in absolute values are probably not as good as relative values. We've got first order effects, but the tighter you put that down, the more accurate it needs to be. And so I just don't like to sell it below a regional level. Then you can take pieces of it for like a jurisdiction within that region. But that's where I would suggest, because it was estimated at a block group level, so you definitely don't want to go much lower than that.
So,
I
yeah.
would
Brian?
like to add
Okay,
some.
sure.
There are a lot of differences also in the policies that you can model.
Mm-hmm.
So RSPM has a lot more policies than RPAT. So you can do like pay as you drive, insurance is RSPM, you can't do it in RPAT. You can do more with travel demand management, more with parking policy. So there's a big difference in the suite of policies that you can model.
Right, and I will say from a development standpoint, the new stuff that we're putting into quote-unquote VisionEval is principally landing in the RSPM model. It's not something that, that's the one that is the sort of focus for new development and extension, because it represents kind of the best available set of stuff. I mean, it has the greatest number of policy options and so on. We have done some work already, and we'll probably do more to make as much as possible the different models interoperable, with the idea that eventually the key difference among all of them is the level of geography at which you want to take on the problem. I mean, that's sort of like the mental map that we have of where this is going. So I saw a question there, and then we'll come back to Christy with hers.
Maybe I'm a neophyte when it comes to VisionEval.
Mm-hmm.
I have a lot of experience with R.
Uh-huh.
And I'm familiar with the base data used to train some of these models, and so I'm just wondering, can you answer questions that are related to something like environmental justice when it comes to transportation? Or are the data disaggregated enough to say households with this number of individuals under 18 and then add socioeconomic status as a layer on top of that to get at transportation?
The short answer to that is yes, but you have to do a certain amount of mining of the data when you get done with it in order to do that.
Okay.
I mean, it is actually doing the disaggregate analysis. You can go in there and sort of look at target populations by characteristic and ask about them, you know, income strata, for example, and so on. This is one of the, what we've considered in the development plan for VisionEval, one of the quote-unquote low-hanging fruit is doing a sort of, you know, just unpacking the equity analysis and enabling people to set up criteria for how would I like to slice this and then producing the differential reports. Because there are a lot of people who have exactly that question, and this in principle is a great tool for doing that because it's got all the stuff you need inside of it already.
That's that really rich data set. We have these households and we have every single household in there, so you can separate out the ones with kids or the ones with low income or whatever. We don't, you know, they're located in a general sense of block groups, but to the extent that you sort of believe all that. But still, there is, we think that there is, be great if somebody would want to come in and look through it like that, because it's got all this richness, but we're not using that yet. Nobody's actually, like you said, unpacked that and sliced it in that way. But the households have all sorts of attributes, and that's why we can go to the ITHM model, because it says, here's, you know, the bike trips and the walk trips, and that for this household, and they were chosen there because of the age of that household, they get more trips or they get less. So there is some of that sensitivity in there at a household level, so you could take those households and separate them out and see how they're different in terms of their outcomes.
Right. So the stuff you would need would be there, and the development path for us is to write a module for VisionEval that basically does that analysis, where you could configure what are the particular characteristics I'm interested in summarizing by, and have it, you know, concoct reporting based on that.
So it would be up to your R skills of going into this database, like you showed, one row for each household.
Yeah, and you know, as much as we like to think, oh, this is a simpler model than big travel demand models, fundamentally, when you're going to be doing lots of thinking about lots of data, whether it's going in or coming out, you're still going to have to do some work.
Yeah.
And so that
I think there's, you know, if you're familiar with R, there is in the newer VE reports module, which is on the ODOT VisionEval site.
We're working on getting that up.
Yeah, we'll get that.
You can do the queries to get reports by
A little more granular information.
Yeah.
Because I just know those are just really important variables talking with stakeholders and the general public. There may be these transportation options or these energy transitions, you know, in broader senses, then how it affects those specific subgroups and those vulnerable populations.
The bigger caveat, though, on environmental justice that I see is that this model doesn't have a network. So you don't have like, here's I-5 and this part of the city and the traffic on it and the particulate emissions, and here's the exposure of this population. So you can't really get environmental exposure by location. So that is a limitation, and you know that depends on someone coming up with a module to enable you to, you know, to get at that.
Okay.
You know, you can get at, here's the cost, here's the, so it's that location-based exposure is missing from the model.
Right, because say, for instance, we have a congestion model in here, but it doesn't have a network. So we actually just look at freeways as a whole and arterials as a whole, and we kind of say, okay, if the freeways are slow, people are going to maybe gravitate towards. So we have like smarts that do a lot of things, but it's the whole region's freeways and the whole region's arterials. So you're, even though that household's going to get that regional level of congestion and reflected speeds, it's not going to get like its area because it's right next to I-5 or not.
Okay, thank you, that's helpful.
Great.
I know that you already,
Okay.
maybe you already explained this part, but, and the reason that you can't get down to like a county level is because of what you were just explaining. You were saying for the region has this freeway, this freeway, and this freeway, but you can't get down to a county level because.
Well, we can look at things at a county level. You can either look at it at a metropolitan level or at a county level. Those are nice big boundaries. So I think both of those we can get at. It's like if you start to go smaller, like a jurisdiction or a neighborhood, you're going to start to get things that are more aggregate. But a county is a big enough entity that we tend to be able to model that relatively well.
The smaller areas are going to be, yeah.
Okay, yeah.
Right.
I guess, yeah, counties could be some parts of, when we modeled the Portland area, there were three sort of, at that point, we didn't actually have the block group level, so it actually just broke it up into three parts, for the most part, three counties within Portland, so you could report at those individual county levels.
Okay,
Does
and
that
could
help?
you get down to a city level if the city is big enough?
Yeah, so I know in Rogue Valley, we were like grouping it into sort of the Ashland area, you know, the sort of Central Point talent area, that kind of thing, so.
Well, I know it's a different state, but city of Vancouver, it's like 185,000 people, the population.
Yeah, I don't know how many block groups you'd have in there.
Yeah, I don't either.
What are block group size about? Do you have a sense, Brian?
1,500.
Yeah.
1,500.
Yeah,
Okay.
About 1,000 people.
Yeah, so I would be nervous sharing things at a block group level. What we tend to do is a block group, you might, have 4 or 5 block groups, and then I'm like much better. So I think that you probably have several of those, so you could like district up the city, and probably be all right. But you'd want to check those things, like any travel modeler does. They may not report at a lower level because they feel more comfortable at a higher aggregate level. So
Right.
getting a sense for the
I
model.
heard you wrong, because I thought you were saying that you can't really get down to a county level because the data that you need is actually not accurate enough, which maybe I just misheard that.
I think I might have said city. A city gets a little bit dicey depending on how big it is.
Yeah, and I mean, my usual way of describing
Right.
this, though, is to say it's
Yeah.
not really about accuracy at the small geography level. I mean, because we are aggregating things like congestion and the access to transit and stuff like that, we're not representing it with the network.
Mm-hmm.
The difficulty is not so much, I mean, it's a loss of detail. And so what's actually happening as you drill down into a smaller area is the likelihood that what's actually experienced in that area differs from the aggregate average that we're using, even though we're trying to, average it for the area. The differences are going to be enough that you're not going to be able to rely on that particular number. We're going to wash out the differences as we add them up across the region. And so the idea there is, and this is just a statistical effect, that if there's variability in the stuff that goes in and goes out, as you zero in on an area, yeah, technically we're getting stuff that's more about that area, but what we're going to see is squishy and might deviate in practice from what's really there. And so that's where, so it's more that question of like variability and deviation than it is like, oh, is the model actually not working for that area? I sort of describe this as saying, the model is like any digital image. It breaks the city up into pixels. And the catch is that there's only so much information in the pixel. If you zoom in too close, you're going to be seeing this big square block, which, if you broke it up differently, might in fact look really different. But at the scale that we were really developing the model for, which may be the full region, this is a useful piece of information. It doesn't matter if that's actually what was there, but it helps make the whole picture work.
Hi, welcome back. We're now going to jump into a little bit more of the methods, how VisionEval works. Previously, we've had a whole day course largely on these methods, and right now we're going to try to encapsulate that in 60, 80 minutes. So it's not a pechacucha. But it will maybe be quite dense. But I'm hoping that we've reorganized this in a way that can be helpful in just sort of 5 concepts, sort of 5 main points with lots of things like linked to them. But hopefully these 5 concepts will help you understand the main thing, so when you dive into all the other details, they can hang off these concepts. There's 3 basic concepts. We start out with some households. We synthesize those, and they're connected to land. That probably is pretty static. I mean, you can run a couple of those scenarios, but that often stays very static, and then we run a bunch of policies on top of it. The next main step we do is we take those rich households and all their data, we jump right into travel. We don't actually do individual trips and all that kind of stuff. We jump right into travel. That's actually where the big savings in this model comes in terms of runtime. Lots of our policies happen around that realm. And then the last one, main concept, is this vehicles, fuels, and emissions. So now the first two are really focused on household. Now we have to add everybody in, look at all the vehicles, what's out there, what might be out there in 2050 or something, how does that evolve? And this is one of the few models that actually gets to all those different details of the electrics, engines, and all that. And then we take that and you get some kind of fuel efficiency for those vehicles. We look at the fuels and how carbon intense those are, and that gets us to emissions. So that's the other one. That also, the number 3, tends to stay pretty static. Once you sort of have your plan in place as to how these vehicles are going to roll out, you get sort of an emissions rate for every mile. This is how many grams of emissions. That's usually pretty static, and you're just changing how many miles you apply that to. So that step 2 is where probably most of the changes are happening in most of the policies. Then there's a couple nuances to that, and one is congestion. So we'll add congestion to this topic, and I know we don't have a network, but we can look at it in a more aggregate way. It tends to change the speeds, which at least for combustion engines will change some of your emissions and so forth. The other wrinkle is that we have a budget module in here. So each household has a certain income, and so we can look at whether they would maybe prefer to have a car service available. If there's a car service there, maybe not buy that second vehicle. We look at that kind of trade-off, and then the other budget constraint we put in there is for if we get into a recession or prices get really high relative to income, people tend to have a certain budget that they put towards transportation, and we don't exceed that. So we'll change your vehicles miles traveled to accommodate that. So those are sort of the big pieces. I'll get into them in a lot more density, but that's the framework we're hanging off of. And then after we get through all this, we'll talk about, okay, let's put it all together now. What actions can you do in this model? What are the policy levers? What are the scenarios that we can create? And they're embedded in there a little bit is some uncertainties that you can also test. And then how can you measure these? What kind of output metrics do you get? So that's our main thing. And down here is what we've been developing is this primer, which goes through these 5 concepts. So that's what we've been developing here as a 101 way to get into this. I should caveat before we get started that this is the first attempt to cover this 8-hour down into 80 minutes. So it's going to be interesting to see how this works out. To do so, I've created sort of cartoons, animated, so I'll walk through the pieces. At the end, you'll be like, how did we walk through this really dense slide? But hopefully the pieces will make that come out as we animate it. The concepts are different than the code flow. So if you're a coder and you're under the hood, it's going to look different, but the idea is these concepts will be overarching, and then you can understand how the code might have to pull this piece or that piece together to do what it needs to do. So this is designed to aid understanding, not necessarily talk about the code flow. And it is a work in progress, and so see how that goes. First thing to start with is geography. So what's the main geography in the model? What we've got up here is an example of Rogue Valley. So we looked at the whole metropolitan area, and in this case we actually put the boundary right at the metropolitan boundary. We could have put it at the county level, but in this case the M area, metropolitan area, is that. You further break it down into the A zones, which are nested within there, and then the B zones nest within the A zones. And when you put it all together, that's what we've got over to the right. Those are the main building blocks here. There's other overlays to think of in terms of how land is done. We can identify the urbanized area of the metropolitan area. That is probably where your transit system will operate. That's where reporting for highway statistics and things, some of the data is more in the urbanized area. Location type is like you might have smaller towns there. Maybe they don't have transit, so we would call them a town. And there might be different functions for those areas, different than the more urbanized areas. And then there's a trick here that we look at like your population density and things and say you are an urban mixed use area. And that actually does bump you up in a lot of ways to do certain things, walking, biking, some of those things, because you have what we've considered an urban mixed use. And the new module that Li Ming has done will even enhance that even more. But anyway, so that's the geography.
Yeah, and so if I could ask a question, I'll phrase this as a question about these zones, and to say that, well, maybe it's not a question, I'll make it a statement, that the zones are up to the developer of the model scenarios to decide. You get to pick what the zone area is. And the idea is to pick the zones based on the kinds of policies you're interested in and the kinds of characteristics that are going to be different from one zone to the next. And so you may go after the A zones at a level where, okay, gross level of policy, transit provision or something like that, if you're looking at that, or it follows, some political jurisdiction. The B zones, we might be looking at, trying to come up with urbanized areas that have similar characteristics so that we can kind of package this stuff up. And so the development of these looks a lot like what you would typically do with a traffic analysis zone for a classic travel demand model.
Do the assumptions or the potential changes flow across all of the A zones and all of the B zones, or could we, for example, in City of Portland, we're doing this project, Central City in Motion, where we're prioritizing 18 different segments for transit. So it'll be transit-only lanes in 18 different segments. That's a small portion of the zones. Can you make assumptions that change at the zonal level, or do you have to make assumptions that...
I would pull out your sheet, and your sheet says for each of the policy inputs, there's a geography. In fact, the name of each file, each CSV input file, has a geography in front of it. So if you're looking at the pricing policies and it says azone pricing.csv, all those inputs are at the A zone level. So if you want to do something at the B zone, you're not going to be able to do it. It's at an A zone input.
Right. And Brian may want to correct this, but my understanding is that A zone and B zone have to do with the analysis that we're doing and the availability of certain types of information at that level of geography, that we're not always going to have either a model that's responsive at the B zone level, so you're going to have to do the analysis at the A zone level. I mean, is that, that's roughly what we're up against.
Right, yeah. Some of it has very much to do with, how the models were estimated, and you don't want to have a model that was estimated at a large geography and necessarily apply it and assume as though it was estimated at a fine geography. But part of it then also is what can you get the data for? So one of the key things with A zones is the population is synthesized using A zone characteristics, and Tara will get into what it's synthesized at. But you probably would have difficulty getting all of the data at a B zone level to synthesize populations. So, so part of it is what you're likely to be able to get the data for.
When you say likely to be able to get the data for, the data being the base data, the base year data, or the projections of changes into a future year?
Both.
I mean, you could go to an activity-based model and you need all that data, right? We're trying to be simpler, so we're putting some constraints on you to do so.
Okay. So perhaps, I'm jumping ahead a little bit, but perhaps then using this to suss out across the board particular policies that are worthy of further investigation, switching to a different tool to better understand.
Well, and absolutely, and I mean, that really is the workflow that we imagine on this stuff. And part of the reason we characterize VisionEval as a strategic model, because what it's helping you do is figure out the strategy. Are we going to go after pricing? What kind of pricing are we going to look at? Are we going to go after transit provisioning? Are we going to look at other things? And once we figured out either, what are the things that we'd like to explore in more detail, we decide, okay, yeah, we want to ramp up transit, by 15%. We're still going to have to ask the question, can we actually do that? Is it feasible? I mean, do we have the roadway, the provisioning? What would it cost? I mean, there are all sorts of other questions that follow on with that. But the key thing about that is we'll use more detailed models, more traditional models for that kind of analysis, but we will have done the pre-screening that says, we know we're in the ballpark. We won't be wasting our effort on setting everything up for that big model because we've determined using VisionEval that this is a strategy that has the potential to get us what we want. Now we have to ask the question is, can we do that in reality?
So this is the what if, and the how one is a different tool.
Yeah. So yeah, so you're right on it. I mean, this is what the workflow is ultimately going to be.
Okay, so concept one is about households and land. So it brings up that geography distinction because the people you bring in at an A zone level, so those are pretty big. And in this case, you actually specify them by age, and we have two types of households, regular households and group quarters, non-institutional group quarters. So those tend to be we don't have a lot of military, but also dorms and such. So these are people who can move around that are in institutional or non-institutional group quarters, but they're single persons essentially. And so we're using Census PUM as our pool of households that's out there. So if you're familiar with that, it's like kind of a sampling of all those people, but it's also a pretty big geography. So we have this sort of pool of people. We tell the kind of age mix that we want to get out, but they're not in households or anything yet. Then we have on the other side some information about the land. So this is now at the B zone level, so it's more detailed. And this is where we specify, this is the kind of dwelling units we're going to put. So we have single family and multifamily. And so I'm going to put the multifamily here, single family here. You know that for base year, but you can do some scenarios in the future year. Also, where's my employment? Where is that distributed? So that's the land side. Then we need to put these two together. And so there is somewhat of a housing model here that we end up at the end of the day with a list of households, and that was that output that Jeremy talked about, that sort of one line with all this information. Everything gets tacked onto this household. And they have a particular, house that's in one of those B zones. Their workplace is in another one of those B zones. They have, 2 cars. They have, 3 kids and only 1 parent. And, they're in a mixed-use area, right? These are all the kind of attributes there. So these are the kind of attributes we end up with on the household side, and then on the land side or the B zone side. Those are informed by policy. So I've kind of coded everything here that the inputs are grayed out. Those are things that you actually can control or turn dials on. And the blue stuff is where the model has done some stuff or what's sitting in the model. So at this point, you gave us this land information at a detailed level. We had a big picture of all this population, put it together, and this is now in the model a bunch of households. The kind of policies we had over on the land side were, you might put a travel demand management program for this household region or for this work location, so that's in this particular B zone. And so what percent of participants do you have? You might put a car service. We have high or low service, high being something where you might change your car out, and low being the taxi service you have now. I put that in certain geographies. Parking also would be geographic specific in terms of residential. Are you limited in spaces? Do you have worker parking programs like the cash out buyback? Is this a parking fee area? So when people come to shop that they will need to be paying for parking, what percent of people would do that? And then parking rates in those locations. So that's kind of the parking side. On this side, the key thing would be we have this sort of aggregate level per capita income. And so we have a bunch of little models in here that do things for us, right? So we said that we put parking in certain locations, but when people are going shopping, where will they go? So there's sort of a gravity model that figures out where those non-work trip goes based where the employment of retail types are. On the income side, you have this A zone, but we've got to get it to a household. So it's going to take that sort of aggregate income per capita and kind of assign it then to a particular household. Workers, also, we have to pick their location, and then we have to figure out how much autos you own. And so each of these modules are pulling from the attributes that we may have pulled in already. So they all have, you can look at all this detail on the website about how all those modules work. There's a couple things I've added over here because we typically have not been using those, but they're kind of interesting. You can say the worker rate, hey, we're in a recession, people aren't working, the different age groups are working differently. Our seniors are starting to work more than they used to, and the licensure rate might say, hey, somebody wants to say the millennials are going to change everything, they're now no longer driving, so let's change the licensure rate just for that and see, well, yeah, that might be true, but there's still all these other people driving, so you can get to some of those questions. So actually, let me back up. So at each of these concepts, I want to stop and see, does this make sense? Any questions on this particular concept? Yeah.
So I see that we have like the attribute of the number of autos, but does this also feed into like the type of vehicle that?
Yeah, we'll get to that. That's in the concept number 3 about the vehicles.
Sarah, what is car service? Is it ride hailing or is it car sharing or something?
It's an aggregate version of that, so it's the agglomeration of the car-to-goes, which are one-ways, and the urban Uber lifts. We're talking right now about putting some more dials in there for, because the Uber Lyft is a later thing, and we were thinking you were driving them, so now there might be some sort of deadheading traffic going on. We do have a cost rate, so you could dial that down and say there's no driver anymore. So it's a strategic model, and so we're putting a car share in, and we'll talk a lot about what that means for budget, because if you have a high service and you have an Uber Lyft available to you at all times, and that is cheaper than you buying a car, you're going to have that choice of wanting to do that. So that's the key thing here, is this auto ownership understanding of car service.
And I will say, this is part of the reason that we try to make all of the information about the model transparent and available, because people will ask questions like that and say, is this model going to give me useful information? Do I have to make an approximation of something? And it's the kind of thing that we're using to prioritize research. So I'm in the process of starting a project now, separate from the pooled fund that's been doing the core development, to really look at specifying, strategic level models that can look at things like car sharing, deadheading of zero occupant vehicles for stuff like that, kind of elaborating some of the multimodal stuff that Liming has done, specifically looking at questions of automation and vehicle connectivity and sort of information support through the system, in the hopes that we can get that back into VisionEval at the same level of detail. But the idea there is really to make the system extensible in that way, so that people can do focused research on how do I express these assumptions, how do I analyze this phenomenon, and take it forward. I mean, I'll hand it back to Tara just to keep showing you that there's already a lot of useful stuff in here. And even though we may not have a fully specified model for some of this stuff, you can make approximations if you're careful about understanding what's going into it that can help capture what might be the effect of that, at least for discussion purposes at the strategic level.
And I think we're sort of figuring out, because the model is simple enough for a researcher or someone who really knows R to go in and do a new module, it's dynamic, right? Like, what is VisionEval at a snapshot in time? It's almost evolving, because right now ODOT's adding on these other features, and he's got some research here on AVs. Like, what is it at any one time? I think Jeremy has this vision that the modules are things you decide what you want to pull into your model. So it's sort of challenging in that way, but I think it's also exciting, because you just can't do that with the heavyweight models. It takes quite some time to actually develop those and test them. Any other comments on questions on this? Yeah, Elizabeth.
Are we going to talk a little bit more about the non-work trips portion of this?
Probably not very much.
Could you maybe just briefly describe how that input is created, or what it covers?
For the non-work parking?
Yeah, well, is it just non-work parking, or is it non-work trips?
So to get to parking, we need to know how many trips go to this B zone, because there's a parking fee in that B zone, that 20% of shoppers' non-work trips to this zone get a fee. So we need to know which of the trips that this household is doing, and we don't really have a lot of trip information in the household. We really jump to VMT. So we need to know kind of which areas they're going to frequent in the region, and so we look at where the retails are clustered, and that's the more likely place to go. Does that help with?
I think so. I was just trying to wrap my head around how exactly that piece came apart, because the work trips made a lot of sense to me.
Right, and actually when I talk in the next module, it is about household travel and the multimodal, so we'll get a little bit more into that. Okay, so I'm going to move on to concept 2. So this one just got us to this group of households. Really, we haven't talked about any other commercial vehicles or anything, right? This is households, but they have a lot of rich attributes now. They got all this kind of stuff, and they're tied to B zones, both at work and home, that also has some attributes and maybe some policies. Okay, so concept 2, multimodal travel for the household. The main core of this is that we're calculating their VMT. Then we go in and estimate some trips and break it up into parts, but largely we look at this as VMT. And this originally was a greenhouse gas model, so we didn't care about the other modes and so forth. So we have added those in, but the main thing is we start with VMT. So how do we get to VMT to calculate the households? Well, we know we just talked about in concept 1 that we have this household with all these attributes, and this is this individual household. We know their particular income. We know their particular living in an urban mixed-use area with 2 kids, right? We know that whole like combination of things, and they're going to make a different decision than the 2 seniors that live in a suburban area, so forth, that don't have access to transit or whatever. So these attributes come in, and that's a big part of us guessing the VMT. One thing we're adding here as we look at travel is we need to add in the transit. So the transit comes in 2 ways. One, through the transit supply, as we call it. So basically it's the whole service miles, your revenue service miles for the whole metropolitan area. So we break it up into 8 modes like the National Transit Database does that transit agencies report to. So we go to that for history. So that has some demand response, and it also has like 3 bus types and some rail. So a lot of people might just only have a bus type and demand response. But so anyway, we have that richness, and they roll into 3 different kind of vehicles we'll see later. Vans for the demand response and buses and so forth. So anyway, that's the transit. Now we also want to get that to the people, right? So can people access this transit? So we're developing these Ds of the built form, which tells you about that zone where people might live, like the density design. Is it a mix of diversity, so it's a more mixed use? Is it accessible? So one of the accessibility things is that have access to transit. So there's a transport D, actually that probably should say transit D, which we define as the PM peak transit stop visits within a quarter mile. So we're trying to go for the peak period, and do you have access within a quarter mile? We're dealing with these pretty large zones, so it's somewhat aggregate, but you'll still get the lines of the transit and the B zones that are connected to it.
And why quarter mile?
This is pulling off of research, so we had to estimate the models, and so we had to come up with data that told us what those B zones were in different areas. And so there is something called the EPA Smart Location Database. So for all the block groups in the whole US, it has defined a whole bunch of D variables, which we borrowed when we estimate this. So the transit one, there were a few to choose from, and this is the one we chose. You could re-estimate it with another one of those Ds, or if you had access to more data, those are options available.
The reason I'm asking that is as we move forward, especially with the strategy we're looking at and the ultimate goals that we're trying to achieve, redeploying fixed route transit resources to more frequent service, and research, at least the research we've been drawing on, uses a third to half a mile for that.
Right. So this is an input that's grayed out, so it's an input. So you might just say, I'm going to trick the model and make it think that all these other places have access to it when I'm extending that distance.
Right.
So it's an input you could play with as a proxy for your policy. So one way to deal with it.
So finally, the advantage of all of this, instead of like running a heavyweight regional model, is that it's kind of like a simplified version,
Right.
that is faster, basically. And
Yeah.
But then I think that for a couple of questions, for example, I don't think that it would be the best tool to analyze, for example, a few
Air quality?
names, because that seems so much specific and it seems so much like a larger scale. So like looking to the macro kind of like structures of like how develop, but then if you're modifying one transit line, probably it's insensitive, the model is insensitive.
Right. So you're going to want to do a big hammer on
Yeah.
this stuff, but it will give you order of magnitude
Yeah.
relative to another big hammer you do, maybe not on transit this time, but on pricing, right? So you can get those in a relative sense by comparing these. But a particular project, I would agree, this is not a project level tool. That's where I talked about that funnel, where we're up in that strategic conversation about big categories of inputs.
Okay, but then for example, if I'm, I don't know, analyzing the Southwest Mass line or something, that's kind of big, but also it's one line.
Mm-hmm.
Will you say that then the appropriate also like then is a part of doing this, probably your first stage is also going to the deep after that and doing the
You would definitely have to do NEPA, and you would not do that with this model. But this might say, hey, what if we did, instead of, in addition to the southwest, now we got other corridors, maybe we do 2 corridors, or maybe instead of spending that money there, we spend it on electric vehicles. Or not electric vehicles, but like electrify the buses, right? Like you can make those kind of trade-offs, but since the transit is a little more everywhere, you're going to have trouble getting those particular projects to happen. This Transit D is a little bit helping you to say, we put this in this area with these B zones where these people particularly live, but until we get to Li Ming's model, it's not even going to be that sensitive to that.
Yeah, and part of the reason for doing the discussion we're doing is so that you understand what the inputs are and what the sort of level of aggregation is. Because what you can ultimately do with this model are compare the outcomes of different values of those inputs. And so the question you want to keep asking yourself is, and you know, going back to the example Peter was giving before, how do I represent this thing that I'm considering in terms of these inputs? And I mean, and there are a lot of things like specific projects that fall below the radar. There's no way that you could change the inputs to capture that specific project. I mean, maybe at a broad level in one zone you could say, all right, better transit provision than we had before. Because what's going to happen at the back end, we're not going after this model to look just at gross levels of, say, greenhouse gas emissions. I mean, we get a ballpark estimate of that, but really the value of the model is not the number. It's the ability to compare differential outcomes that result from manipulating those inputs. And so what we've tried to do with the model is scale the inputs and have the right kinds of inputs so that you can reasonably capture those kind of large policies happening at the level of, you know, basically A zones and M areas, or combinations of those. And then look at, you know, sensitive estimates of the outputs that will enable you to judge how much of a bang do I get if I make this investment or don't make this investment. I'm interested in these performance metrics, which ones are going to move and how much. And so it's always about those comparisons and not about, you know, a forecast number that you might use for something like NEPA where you need the specific impact on this specific neighborhood from this specific alternative.
Which reinforces the ability that you can run this a bunch of times, so then you get all this comparative stuff. Peter?
Are the outputs a single point estimate, or are they a range? Because
The outputs are single point, but you're running lots of scenarios, so you get lots of points.
okay. And do we see, or for example, in certain strategies, there is a wider range of potential outcomes than there are in other strategies. For example, the TDM, for example, is a good example. Depending upon what type of TDM strategies there are, you can have a much higher or a much lower effect. So.
Right. So you would specify in the input 3 different scenarios. Low, this doesn't take off the way we thought it would. Medium, maybe it's your reference, and then a high or something like that. You would specify that on the input side. Okay. The other thing up here, in addition to transit, is to get the roads. So as I mentioned, we're not doing with a network, we're just dealing with the road lane miles. So we need to have some capacity because we're creating all these households and they're going to have demand. So we want to put the demand and supply together. So our supply on the roadway side is just strictly how many freeway lane miles do you have in your urbanized area? How many arterial lane miles do you have in your area? And we'll talk about that as one of the adjustments of it's one of the concepts is to talk about congestion. Okay, so given all those attributes, given the new transport side of things we added, we take that transport supply and we do it per capita because that seems to be a pretty effective way to sort of predict VMT is to know the density of your road miles and the density of your transit service. And we convert the transit into bus equivalent so that we're dealing with apples to apples. So those are sort of submodels. And then we really rely on the 2001 NHTS and we just jump right into that VMT, right? We didn't. In a traditional travel model, you'd be figuring out here's generate, and where do they go, and all that. We're not doing that. We just jump right into the VMT for the household. Couple things then we do after we get that first cut at VMT is we can reduce it because they're in a TDM program either at home or work. And that should be a pretty quality one because we have a reduction and it's a pretty simple one. You know, if you're in that program and you get like a 5% reduction in your VMT, right? And that's super simple, kind of too simple in a way, but that's what we have for TDM. And so then this is the other one, which is for bike. So We think of this more as a broader than bikes. It's a short-term diversion of single occupancy vehicle trips. So these would be trips less than 20 miles round trip. How much, what if you could divert them? What if, for whatever policy we're at today, we can look at the census and we're, maybe about, 5-7%. What if we could go to 14% and double that? So that's the input for the bikes. It's not how you would get there. That would be a whole other conversation. It is like, what if this could happen? We would reduce it. We'll play it out and see how it affects congestion and things like that. In that, we have to first identify in the household what are their single occupancy vehicle trips by distance, so that we can pull out those short trips. And we can say, okay, now everybody has their short trips, but which ones are actually going to divert? Is it going to be, we'll look at the age of the the household, some of the attributes of the household to say, okay, you're more likely to do this maybe in the urbanized area where you have shorter distance in general, and so forth. So anyway, there's a diversion model here that you can look into the details about that. Couple caveats here, because that VMT is adjusted by some of the other concepts, so the budgets may affect whether you own or do car service. So we tend to think of owns and car service vehicles are all the vehicular miles that are driven by the household. Whether they own it or car service doesn't quite matter at the end of the day. Each household is going to have its own share of that, and we often group those together. And so we have this budget model, because if you actually don't own it and you're doing a car service, you're going to probably tend to do slightly less. So it is important to know whether you own. So we'll talk about that a little bit next when we talk about vehicles. And at one point, we're going to say, if you're in a high car service area and Uber Lyft is prevalent and maybe it's at an automated level, so it's cheap, you might sell off your car or only have that first car and not the second car. So concept 5, we'll talk about how budgets get to that. Concept 1, we had some programs at the household level and that affect people, may affect their income. So if you come in here and you're in a pay-as-you-drive insurance, your insurance that you're paying every 6 months now goes on a per-mile basis, so we take it out of your income, so your income looks a little bit bigger. So there's some adjustments we make to income because you're participating in some programs.
Hey, Terry, quick question. Is all the roadway information you need available in the highway performance monitoring system?
Yeah, so we just take those road lane miles out of the HPMS for base year, and then you have to predict their growth in the future year. Okay, so then, only then, do we go to the alternative modes. So, and a big trick here is that overall VMT that we had calculated up there with those policies now feeds into the alternative mode. So we take that same NHTS data and we jump right into trips and miles for these different areas, or these different modes. And one of the variables in there is this overall VMT. So if all of a sudden I got a congestion pricing policy and I was restricted from driving, I might do walk and bike more, right? So this overall VMT is going to have an indirect impact on what the alternative modes are. Okay, so I think that might be all in this concept. So before I leave this concept, any questions, comments, ideas? Making sense? Okay. All right, concept 3, vehicles, fuels, and emissions. So this gets to some of the questions there. So we've only been talking about these gray areas, the household vehicles, right? They're either in a car service or something that they own or lease. So those areas, and we actually further break them down into an auto or a light truck, or an SUV is considered a light truck. So why we do this is because those light truck frames have a lot different fuel efficiency than autos. And in fact, there's not a lot of electric light trucks available right now, so they're going to have a slower adoption rate than autos. So anyway, when we're in the light duty vehicles, we split those out by those vehicle types. Then we go into powertrains. So we have some nomenclature here. I think I explained it more on the next one, but there's the combustion engine, the ICE, the hybrid electric, your Prius, the plug-in electric vehicle. We're getting more of those, and that has both engines, and then the pure battery electric vehicle. So most of these have these options. And I should say that for households, we actually are looking at each individual vehicle, right? We had the whole household, all their attributes. We knew that they had 3 vehicles, and so we actually picked each of those vehicles and so forth. When we get to these other services, they're really fleets, and we don't think about them the same way. They're not individual vehicles. We know we have a certain amount of VMT that's occurring with car service, a certain amount of heavy truck. Maybe you only have a portion of the full state's heavy truck that goes through your area. So we think of this more as VMT, and it's all the things on the road. It's not your vehicle as much as what's on the road. So when you think of it as VMT, you don't really have a plug-in which has a little bit done at a hybrid level and a little bit done at electric level. You split those up. So your VMT is either going to be at the hybrid or the electric if you had a plug-in. And that's what would come in as that. Okay, so that's the powertrain options, the vehicle input adjustments. So there's things you can do to change those powertrain options. Not a ton, but you can start to change the vehicle age. So if you have older vehicles, they're going to tend to be more combustion engines. If you say everybody's going to have, right now I think it's about 12 years as our average life in the state for autos. If that would jump up to like 8 or 9 years, we're going to turn over, and the newer vehicles are a lot cleaner. So you can dial in that age. You can also say people are going to be buying more autos than light trucks or something. So that could change your fuel efficiency. In the case of households, I've got that blued out up there because the vehicle sales are something that are kind of complicated, and they're really set at the federal or state level. So we come in with default values, and you don't change them very much. So it's not something that's a dial that you can adjust here. Longer term, you can adjust if you're sharp at R and you have access to maybe DEQ or DOE to help you with like what are some alternative scenarios there. You can come up with sort of a different default, but you have to sort of be at the code level, rebuild some packages. Whereas in the other cases, you're specifying things a little bit more. And then the last thing, so now that's all about vehicles, then you get to the fuel. So pretty much everybody has about the same fuel. You're going to see that gas with its add-in of ethanol is probably going to be the most dominant for the light-duty vehicles because we have a certain minimum in our state of 11% ethanol. Some transit agencies might go further with that. Then when you get into some of the commercial service, you're probably going to be more diesel with the biodiesel as a blend, and then get to some natural gas, which could be compressed natural gas, or often the heavy trucks have the liquid natural gas. And then there's a sort of cleaner version of that, which is the renewable natural gas or biogas, and that's where you might get it off the landfill.
So in some of the work we've been doing, I mean, I don't know this, so the people that know this have been characterizing the difference between clouds as diesel and renewable diesel. Mm-hmm. And is that a factor we can...
Yeah, so you can specify the carbon intensity of the fuels. There's a default there, but if you disagree with that default, there's a way for you to overwrite that. Okay, so I think I talked about, yeah. So here's like all the options you have and how they're different for our different vehicle groups. And it's important to note that we have all these other vehicle groups. But I'm going to jump back to households for a moment because we do the most detail for them because we actually look at vehicles. So we had that household. For the household, they're going to we'll have a vehicle table, and there's a household ID, so it'll link it back to that household. And the households might have 2, 3. I think we have a maximum of 5 or 6 vehicles. I think we allow. So you'll have that listed there. And then we're going to put some attributes in, and some of those will be things that we predict based on the rich household information we have, and some of them will be lookup tables. And I'll walk you through that. The other thing to note is we set this up for every worker, because every worker needs access to some way to get to work or some kind of auto vehicular option. And so if we don't have enough autos in the household for every worker, we'll have a slot in there, and we're going to say it's a car service is their access.
Driver.
Every driver? Okay. So every driver would have an option of they have an own vehicle tied to them, or they have a car service tied to them.
Actually, it's every driving age person
Okay.
in the household has access to a vehicle. We don't really accommodate the future of non-driving age kids, you know, a 5-year-old going and ordering up an autonomous vehicle to get them to school. So it is every driving age person. If there's not a vehicle in the household, then they've got car service.
And that car service may be in a place where it's just like today's taxis, not a lot, or it could be a high level where you're actually, able to use on almost as well, maybe better, than your regular vehicle. So those are the choices we make initially, is it an own or car service? Then we can make some judgments about the age of that vehicle, whether it is light truck or auto. So we take the rich household information again. Those are some of the more important variables for this question. And the one policy thing you have here is you can say for each A zone, so I know in the statewide model, each county is an A zone, and so I can say the light truck share, which is quite different in some counties of Oregon than, say, Multnomah County here where we are. So you have that sort of gross variation, but then you'll get assigned to an individual vehicle with or individual household with a distribution. And so moving that stuff into those attributes, we have this vehicle age and light truck models, which really is driven a lot by the income, but also a little bit on like how many vehicles you own, and it relies on the NHTS data as well. Yeah, Peter.
If you're using 2001 NHTS data as the baseline, we've seen some pretty dramatic changes just in the last 3 or 4 years, particularly on the car share side, because we're in left 12 million trips in Portland. And on the urban delivery side as well. And I'm wondering whether and how you capture that level of increased use, or is that something we would need to go in and tweak?
Well, I think the inputs for 5 years ago would say there really isn't a high car service anywhere. And so you would never get any of these car services mattering, really, right? Because it'd be low car service. It wouldn't be that influential to you changing and using different vehicles. So in that sense, your input was specifying. Now today you'd have a little bit higher. In the future, you might have higher yet. So that would be on the households side. On the commercial vehicle side, that's a different question. I'm not sure, what are you asking about? That just their
We've seen
mix?
a dramatic increase in the number of urban delivery vehicle trips, actually pretty much everywhere.
Right, so you're saying the VMT might change for commercial vehicles relative to what it was in the past?
Significantly.
Right. We do, and I'll talk about this in another one of the in congestion, when I have to bring them in and talk about their growth rate of the commercial vehicles. So we have different options. You put in the VMT for your base year, and then you talk about a growth rate and how that growth rate is based. So that growth rate has options of being based on income, based on population growth, or based on the household's travel. So if you're basing it on the household's travel, the household will be like, I'm not traveling any much because I'm doing e-purchase and it's coming to me, then it would go down with that. So that might not be the option you want to grow your commercial vehicles. You might want to do it either on income, which actually grows quite fast, or population, which is a little more stable growth. So you have some play there as to which one of those options you want for the growth of your commercial vehicles. Yeah.
Another angle, another kind of aspect is the vintage of the data. We are, for the travel, you're aware of that the 2009, actually now the 2017 NHTS is out. In our own region, the 2020 or 2021 OHAS is kind of at least moving along. So we are, at least for the V travel demand module, we re-estimate the model using 2009 data. In an ideal world, we certainly want to update all the modules to the latest, but at the same time, utilize all the historical information that we have in the from 2009, 2001, 2009 to 2017 NHTS data. But that's probably a longer term.
Well, right, but it's important to understand the role of the NHTS data in the system, because where we're really using that, and this goes back to what Tara was describing with the households and how the travel is broken down and all the rest. What we're getting from the NHTS is a breakdown of distribution of characteristics in what is essentially the model base year. And I agree completely with what Liming is saying. At some point we've had 2 additional NHTS surveys since this research started working for VisionEval, and redistributing based on that change would be important. But I mean, the interesting characteristic of that is, yeah, there's a difference in the baseline distribution of some of this stuff, but we can capture that when we start looking at the future years, because the question we're asking through the inputs is, at what rate is some of this going to change? And we are going to be looking at redistribution of characteristics compared to the baseline. And so what Tara was just describing in terms of you have control of these factors that say how much will this be different in the future year, you can readjust those, because all of that is basically going to be an assumption. The thing that we're not doing is assuming that, oh, everything that was described in the 2001 NHTS is just going to get stretched out into the future year. We're going to unpack it into its determinant characteristics and allow you to stretch each of those in different ways. And so, in that sense, there is some nuance with that, but there's still the open question of, well, what are we assuming about the future year? And this gets back to the question saying, well, I don't really know, it's going to be somewhere here. How big a difference would that make in the things that I'm going to compare? There's a room for a dozen more scenarios that I can evaluate and compare. So that's the kind of mental thought process of this. And certainly we want to get back to, rebasing this stuff on more recent surveys. And I don't think that that's an enormous, if we were to pull down the 2017 NHTS and decide that we were going to redo all the VisionEval modules with that, the apparatus is there for doing it. And I don't think that we would actually find, I'm looking at Brian because he's the one that went through all of this before.
To what you're saying. So with the household survey data, the car service is relatively new, at least the high performance, high level car service. But we do know that accessibility to vehicles increases travel. The more vehicles a household has available to it. So having Uber or Lyft at a high level increases travel. Now, it makes travel possible for people who don't have that car, and people have found that with, like, the study in San Francisco that was done on that. Now what is different, so a basic model that says that you estimate that says the number of vehicles you have available affects the amount of travel is true. Now, one thing that is different that you have to account for is if you have a high level of car service available, well, a household could save money if they don't, if that car service costs less per mile than the cost of car ownership, then hey, there's going to be a tendency to ditch the car. Now, you can put in the model and another factor, which is a matter of your judgment, of what proportion of those households would actually ditch a car. But then given that, the amount of travel they do is going to be subject to their budget. And when they're using a car share or a car service, and if they're paying out of their pocket $2 per mile, versus, if they owned a car and they're paying out of pocket, 50 cents per mile, they're going to use that car share vehicle, car service, less than they would if they owned that car. So that all gets accounted for in the model to adjust ownership for car service availability at a high level, but also adjust the amount of their travel to account for the different out-of-pocket costs. And the model then helps you figure out how all that balances out.
And that stuff's not based on 2001 NHTS.
No.
The NHTS usually is a starting point for us. I think we talked about it in the last one. There was a heart of that at the beginning to get the VMT from the NHTS, but then we adjusted it for this, and we adjusted it for that, and we adjusted it for this. And those conditions might be quite different in one scenario versus another.
And the budget comes from consumer expenditure survey data over a long period of time.
Just without going too deep into the rabbit hole, what we're seeing is people are willing to take very expensive trips, very short distances, because the friction is gone, or probably for a whole variety of reasons, but the friction with a service that already has your credit card is exceptionally low. We're seeing a significant substitution of high-cost Uber and Lyft trips for low and no-cost bike and transit trips. And so the traditional economic assumptions aren't holding with Uber and Lyft type services. So just we we don't need to go deeper at this point in time, but I'll just put that out
Right,
there.
right. But I don't think any model's getting that because we just haven't had that data till like, you know it, we all don't know it quite yet, right? So it's not in our models yet. We'll evolve.
Which is something, yeah, we're interested in trying to figure out how do we plug something like that.
And kind of validate
into,
it.
Yeah, face it, that we do have trip data.
Trying to get it.
Well, we'll have to test it with it, but I'd say it probably accounts for some of that, because what it's doing is saying that people have more cars available, right? The Uber and Lyft is essentially a virtual car ownership. And since the model increases VMT with car ownership, as Uber and Lyft expand in service area, you're gonna see this increase in virtual car ownership that increases VMT. On top of that, and this is where some enhancements will have fairly shortly to account for deadhead mileage. The deadhead mileage of these services can be pretty large, you know, and you account for that, and you can see this.
And a dial for how much sharing you think is happening with those, which could be nothing, or a future where you incentivize that and it's much higher. And I guess the other thing to note is that the car service isn't subject to the parking fees, and it also, if there are any, and it also, we have an access time to get to your vehicle, and how that compares to access, well, it's on both ends, to an owned vehicle. So you might be able to get right into your garage, but when you get there, you have to walk from your parking, and so it's this kind of averaging out of that sort of friction that goes away with the car or Uber, or whatever, the car service. Okay, we'll get more into that when we get to the budget, because that's a big part of the budget thing. Any other questions before we move on? Okay, so we've now estimated just these couple attributes. And the next thing is to say some lookups. Okay, so we know that now that it's, let's say it is an auto, so we can go into our auto table. And this is the sales for vehicles of different years. So down here is the different years. So you can see back in, I guess it goes back to 75, because we have a lot of old vehicles out there. 100% combustion engine, right? Now we start to get into reality you get some hybrids. We're seeing Priuses out there, but as we go on, this is what is some of the defaults in there. This is the high-end case that ODOT's run, if you know about our statewide transportation strategy. So this is what we'd like to have happen, is we have a bridge of hybrids, and then that peels off into electrics. We're finding we don't have that bridge. Electrics are coming in a little bit faster because we actually have them today. But anyway, nonetheless, this is what we do, is we go look up into some table that tells you what's the powertrain that this vehicle, in this vehicle table, and then we go through each vehicle and they each get assigned a powertrain. There's actually two tables for the household, right? If they own a light truck, it's a different table, and I haven't really shown that, but anyway, so there's multiple tables, and then once we know what kind of vehicle you have, I have a hybrid, and it's a from a certain year. I go look up and say, okay, it's a 2015, and it's a hybrid. Hybrids are in red, and there's a light truck and an auto, so it's an auto, so it's up here. So then that's another thing we look up there is what's your MPG, and if it's electric, we'd put MPK, miles per kilowatt hour. If it's an electric, you'd also sort of set other attributes about the range. So we have other lookup tables that tell you this is an electric vehicle that can only go 100 miles, or maybe in the future we get to 500 and nobody really cares anymore. That's a variable we have in here as well. After we get all that done, we have all these vehicles, and then we can say, well, what's the mix on the road, right? Because the mix on the road, you can see there's an age on the x-axis there. And if they're older vehicles, they're going to tend to be that electric, but you can see the new ones. But we don't have as many of the old ones, so it ends up to be this conglomerate, right? So what's on the road doesn't reflect what was sold last year. It reflects this mix of ages, and the bar chart on the right is saying, now we can look at what's the mix right there on the roadway, because we have a mix of auto and light trucks, and they have a mix of ages. So it's important to know that there's this distinction about what was sold, which everybody talks about, but it takes a while for it to trickle through the actual fleet and have an impact. So some caveats here when we do, if we went through this process and we assigned somebody an EV, but that household lives in a rural area, that household may live in a rural area, and then when we do this daily trip length model, we find out, hey, their distribution of daily trips are a lot longer than can be accommodated in that 100-mile range. So we're not going to assign them an EV, we're going to give them a plug-in. So they will have that backup and won't have the range anxiety. The other reason you might do it is, hey, I live in an apartment, I don't have charging available to me, I need that backup. So the switch can happen that if we assigned you electric, you might actually end up in the output to have a plug-in. Other things that might affect this congestion, when we go to that module, it will affect the MPG. So we have a starting MPG, but then it can change. And also through policies, because you might be an eco driver, and you get assigned to having gone through that program, that kind of thing. And then the Concept 5 budgets, as we've been talking about, might affect your auto ownership. And you might have that partial ownership of a car service, so forth. So this is the things that might adjust it. So that was all households. Now when we think about those other vehicle groups, they are fleets, as we recall. We don't go through this process because we don't look at individual vehicles. We just look at all the VMT that they do. So it's a simpler approach where we just take sort of that end product in a way, and that's specified as an input. As to each, maybe 5-year period or base and future year, what is your mix on the road with all those ages together? And then you have some input dials that we talked about in the last slide that you can change on what's the mix, what's the average vehicle age, and vehicle type. So I think that's all on this slide. Any questions before I move on? Yeah.
Sorry, could you just speak briefly how you treat the rural residents once again with regards to the plugins and things like that?
Right. So remember, each of these vehicles in the vehicle table is tied to a whole household with all those attributes.
Yeah.
If that household happens to be in a rural area, they might have a couple things. They might have an average percent light truck for their county, which is really high. So they're more likely to get in the table that's not adopting as fast because they want to keep with their light truck. So that's one place. And then they might, when we do that daily trip length model, they are maybe unlikely to be able to accommodate their trip lengths with a range-limited vehicle. So the only thing we would do is we wouldn't bump them back to a combustion engine. We would say, hey, you're out here and there's no combustion engines being sold, but instead of being electric, they're a plug-in. So there could be more nuance where you would actually feed this back further into the chain, that this chart might change, but right now this chart is fixed. The only thing you can do is switch between the dual engine to get rid of the range anxiety.
Okay.
There's an assumption that actually there's a part of the VMT model also models the distribution of VMT by day of the household.
Okay.
And that's allocated to vehicles. And so there's an assumption in there that a household will get an EV if they can meet their 95th percentile day need, assuming that they start with a charged vehicle, so that the household, that they have charging at night. There's also an input that you can provide that gives the proportion of residences by type, multifamily or single family, that would be able to have charging.
Okay.
So you could assume, hey, multifamily, no charging available.
Right.
And that's gonna limit the households that can get those EVs.
Okay, so there's some checks and balances to
Yeah.
Okay,
Yeah.
Great. That's good stuff.
Okay, I'm just seeing the time, so I'm going to probably go a little faster here. Okay, so then you get to the fuel mix, and so this is our mixture of fuels that are possible. I talked about how there's sort of basic fuels, whether it's gas, natural gas, or diesel, and then you have sort of a blender that's going to make that a cleaner fuel. 3 ways for people to input those. You could use a default and not input anything else. Of course, then you're relying on ODOT, and ODOT's actually not using the default, so we're not looking at them that closely. So a little danger if you use option 1. Option 2 is you can do all the details, so it basically looks like what the defaults are, and that's where you say, for each of those 8 vehicle groups, what's the base mix of fuel? And you can say it's all gas or it's all diesel. And then what are the blends? And there's statewide blends, and maybe you want to push that further. So, and then once you get to the fuels, you want to know what the emissions rates are for that. So we have a fuel carbon intensity for each of those fuels, which actually that's what this looks like. So this is for household vehicles, for autos, separate from like trucks, gas, diesel, CNG, same there. And then what blends when you go for gas, what blend is ethanol when you go for diesel, and so forth. Then that just gets you to how many gallons you're doing of each of the types. This will get you to the carbon intensity, and this is a life cycle, well to wheels, not tank to wheels, CO2 grams per megajoule density. So then if you multiply these out, you can say I can get one number for that year. In 2015, the household vehicle, when I get a composite, when I combine all those, I get 90, and then I know that'll reduce over time. We have actually used the composite in Oregon a lot, and then we do it by getting this stuff for history, and then we jump over and start to use it in the future to say, hey, we have a low carbon fuels, and it's supposed to reduce it by 10% or 8% if you take out the credits for the EV sales. So the low carbon fuels can be represented by just a simple reduction of that over time, which is a requirement. How we're doing that, I don't know. This is a what if tool, right? So the what if tool says somebody's signed up to make sure that happens, and I'm going to model it. Okay? All right, so next slide. Concept 4. Yes, so we've done the basic ones. Now there's 2 adjustments. So congestion, how do you do that without a network? First off, you have to set up some initial conditions. So we can't just look at the households. Now we have to add in all those other vehicles. And we're really focusing on that urbanized portion of the metropolitan area. So we have the VMT from Concept 3 for households. Now for those other types, we are going to look at both the VMT for the base year and do the growth bases. So that's where I mentioned to Peter that we're, you either grow with population or you grow with income, something like that. So you set those in as inputs. And then in addition, we need to know what road class each of those 8 vehicle their miles are on. So if I'm on transit, I'm probably going to locally be on arterials, but maybe I have that long one that goes to Ashland and gets on the freeway for a little bit. So it's 5% split to freeways and 95% split on arterials, whatever. And you do that for each of the vehicle types. So that's our initial split. Then we're going to start to balance. So I'm going to show you a little figure here about how this balancing is done. And it's in an aggregate way, just thinking about those 2 road classes. So for each road class, we calculate all those people together on the demand, and we have the lane miles we put in before. So you're going to say, given that, you can go down these curves of the BPR curves and say, what's the speed that should result of that kind of demand to capacity ratio. We get these initial speeds, and then we say, oh, but we put in some ITS policies, so that's a lever you guys can pull. And then we're going to do like we did on 217. We're going to put this fancy stuff in there that, speed, variable speed messaging and all this stuff. So that's some ITS programs, or just an incident response to get rid of congestion. Those are policies that we adjust for. And then we go and we say, the speeds are different between freeways and arterials. I'm driving home and I see that the freeway is congested, I'm going to get on the arterials, right? So we have this, if there's a differential in speed, we'll see people shifting. So this is how that plays out. You start with your total VMT of all these people. We come and we have an initial split. Then we, between freeways and arterials, then they split out into either side, and we come down and we say, well, let's compare that to our lane miles out there that we got from Concept 2. You get some congestion, which gives you a speed. So you got a freeway speed and arterial speed. We adjust it for those ITS programs. Then you get this ratio, like which is better, freeway or arterial, and it'll come back up and resplit the DVMT and keep going through this for several iterations until they're somewhat in balance or the maximum number of iterations is reached. We do have this lambda factor, which I would direct you to Brian, that sort of scales it, whether you're a small city or a large city. You're going to have sort of different sensitivities to this, and this is all based on, I think I put up the urban mobility report. Anyway, it'll show up there, the urban mobility report data that this is based on. Okay, so then you got through all that, and now you've got speeds that are at some kind of equilibrium, and we can go back and do some adjustments. So we go to the vehicles and we change their fuel efficiency, miles per gallon or miles per kilowatt hour, based on those congested speeds. And those fuel speed curves, they vary by powertrain, because if you're combustion engine, you're going to have a lot of sensitivity to that, but if you're an electric, you're not so much, right? So we could have clean congestion, everybody's got tons of delays and low speeds, but no emissions because we're all in electric vehicles. So this is sensitive to that, and you'll see in the outputs that, hey, we put an ITS policy in 2050 when we had all electrics versus putting it in today when we don't, you're going to have different sensitivities to that policy.
And presumably you change the fuel mix for electricity because where you are, you have a lot of coal in the electricity now.
Right, right. Actually, I guess that was in my last slide. I had something that showed up in the fuel that said the other key input on not on the hydrocarbon side, but on the electric side is what's your carbon intensity of that electricity. And we have that changing over time as an input too.
Excellent.
Okay, so then the other thing we can do besides just looking at the speed that this ended up is there's a few things you can do that don't affect delay, but they do affect how fuel efficient you are. And I think this gets a little bit to some of those automated vehicles that they will just not have the stops and starts because we'll just let them go and they'll like kind of slow up and do things more as a platooning. Of course, you can do an eco-driving program that, you know, get your tires pumped up to the right level. That will also save. So these are where those policies show up, where it's not a delay impact of some of them. It's more just how fuel efficient that time spent in the vehicle is. Okay, so that's concept 4.
Did you mention the congestion charges?
Oh, yeah. So when it does this reallocation, it's not just speeds that it's looking at, balancing the freeway and arterial. It's a generalized cost, if you know that from travel models. So it actually looks at monetary costs as well as sort of the speed time cost. So, and so that's a thing you can put in there as a policy input is those congestion fees and whether they're affecting the arterials or the freeway. We can't say which ones. It's sort of affecting all the freeways or all the arterials. So if it's only on half of the freeways, I'll cut that congestion fee in half because it's only affecting half. It's a strategic model. That's all we can do without going to a lot more detail and getting there. So we'll get first order effects of that. Okay, and then there is the data, the 2009 urban mobility data set from TTI. Okay, concept 5, last of the concepts. So we have talked about most of these before, but there's really 2 things that happen with the budget. We can look at auto ownership costs, which is on the left side, or auto operating costs, which are on the right side. On the left side, we've talked about it, ownership can change. So I look at my ownership costs, and I can substitute a car service, or a TNC, for an owned vehicle. We've talked about doing that. This will tell you what prices are considered auto ownership costs that feed into that. And then on the other side, you're doing some adjustments for operating, what you see with every mile. And then we roll that up and say, well, you did this many, you want to do this many miles, but your budget's only this big, and we're in recession, or the pricing on those miles went really high, and you just can't meet your budget. And we'll actually reduce your VMT as a result. So we'll go into each of those 2 budget adjustments. And first I'm just going to talk about what costs. So these are all the policies. So everything in gray are things that the user can play with. The things that are in blue are things that the model is assuming. So Brian's done an extensive job of getting a lot of costs from AAA on depreciation, financing, insurance. So based on the age of your vehicle and how much you drive it, the model's going to calculate that for each of those households. The parking costs, whether you're enrolled in some programs, you can do, and also the annual licensing fees, or if you have sales tax fees annually, that kind of thing. But some of those are actually calculated. You can see over the right, the units are still in blue, so you tell us how many people are in it, and the model will tell you, how to apply that in terms of monetary impact. Okay, on the other side, because that was annual ownership, this one is more operating. So you have also AAA doing the vehicle maintenance stuff. You get a lot of assumptions on fuel costs. Like that's not a policy, but it does change and have a lot of impact. So we do a lot of sensitivity testing with fuel costs as being different prices. Electricity costs tends to be a little more stable. Car service fees. What's the tax on gas? In the gas tax, so that goes to like recovering our roads, right? The gas tax fee. But EVs don't pay that because they don't buy gas, right? So there's this thing in the model that you can turn on to say, I'm going to make the EVs pay the equivalent amount of a gas tax. So if, the average, this is sort of what Origo does, right? If you're in the Origo program, you pay per mile, but it's a zero-sum game. It's the same amount as if you were paying gas tax for the average type of vehicle in the state. So you can turn that on and say all the EVs are doing this, or 10% of the EVs are doing this. That's a dial you can do, but it's still just a one-for-one match. If you want to go further than that and start to really recover your roads, because we're only covering about half of the cost of our roads right now, you would want to impose this VMT fee, a road cost recovery fee per mile. So that's something you can put in separately. And if you want to actually know how much it would need to be if I wanted to fully recover all the road costs, we have a surrogate thing in there where you can actually iterate to say, if I wanted to cover all the fees, and we'll show you like there's assumptions on what that infrastructure would cost and the maintenance on it. If the households were covering their full share of those fees, what would that VMT fee be? So that's a good trick in here. Congestion fees you can put on, we talked about that. Only in the metropolitan areas. Then there's the social cost side. So we can put in a carbon tax separately or a social cost, and you're really saying how much social cost recovery you want to do. Do you want to do carbon tax and do you want to fully recover it or just partially? Do you want to do more than carbon? Do you want to actually look at the noise and the health and some of those other impacts? They've been quantified. Now you just say, I want to cover 100% of them or some other portion. And right now, really, we're covering zero, so we're paying for those elsewhere in our health costs and such. Okay, so then we get to parking costs. We've talked a little about the work and non-work and putting those fees in there. It sort of calculates what happens on the individual trips and how many trips are being made in a household. Pay-as-you-drive insurance is where you're actually paying per mile, so you say whether they're enrolled or not, and it decides how many miles you have and what the rate is. And then, so those are all out-of-pocket costs. You're actually paying those monetarily. When we think about this decision up there that was going to limit your VMT, we actually add in the time equivalent cost, which is both time to access your vehicle. So that was the car service getting to your car or owner getting to their car on either end of their trip, and then the travel time of that trip at the congested speed. So you're thinking about all those operating costs when you're limiting your VMT. So a couple more nuances on that. Here's all the social costs and how they've been quantified. It's a little bit old, back in 2011. We talked about revisiting this, but that's where we've got right now. You can choose just carbon out of it. And again, it's VMT based, right? Because these tend to be per mile the way they've been quantified. And the other thing is the roadway costs. You can figure out how to recover your roads. So here's some assumptions on those roadway costs that we've been using in Oregon. And it will calculate that VMT fee to fully cover the household share of those road costs. Some point in here you need a value of time. So there's time equivalent operating costs. And a lot of these times, these things vary by year. So the inputs you put in are not necessarily fixed, but you can say the congestion fee changes over time, say. Okay. All right, so then we'll go into each of those with a slide. So the auto ownership, car service, this is not what's in the model, but it's sort of to illustrate, the first car, you get a big bang for it in terms of how many miles every driver is going to use it, especially after like, 4-driver household and you get your first car, man, you 50 miles per person. But then the next couple cars, you're not utilizing nearly as much. So this is the idea we've been talking about. Maybe you could have a car service for those additional vehicles, and it's cheaper for you to actually do that than to buy that second car. So could they save money by substituting? So the actual model, what it does is it compares the vehicle operating costs that we talked about in the last slide to the car service cost per mile. Some of those will be common costs between those two, right? But some will be different. And it only does this if you have access to the high car service, because you wouldn't give this up if you had to rely on taxis everywhere. And then there's this one last dial that says, some people are never going to sell their truck and do a car service, right? Or maybe you tow your raft, on weekends, and you're not going to give it up until, the market innovates and gives you some Uber raft towing service. So this is an input dial. You can say autos or light trucks, they're only, maybe the autos can get to 95%, but the light trucks are only going to be at 50% of, kind of a ceiling of what percent they're actually going to switch over, even if it was cost effective for them.
It should say ownership cost, compare vehicle ownership cost.
Right.
To the car service.
So Tara, just a time check that we're at noon.
Yeah.
So
okay. There's one more here, and then I think we were on the wrap-up, so maybe I'll try to get through this one quickly on the budget. So given the observations of high vehicle operating costs, so now we're in the operating cost world, curtail VMT, we apply a historic transportation budget portion of your income as a limit on the annual vehicle operating cost. So over here we've got this data that is from the consumer expenditure survey over those years, and the x-axis is income, and the y-axis is the percent you're spending on transportation. You can see that that declines with income, so at the high end you're in the 30% range, in the lower range you're at the 7 to 10% range. If you have a household with a certain income, if your vehicle costs start to hit those ceilings, and you can see they're higher than the actual data, that blue line that we're using is higher. If you hit the ceiling, then we will start to reduce your VMT. So the actual module calculates sort of those costs, the operating costs, which is out-of-pocket and time equivalent. Yeah. And it ends up, sort of at this, looking at your annual VMT from concept 2. It also looks at your budget, which is this maximum share of annual household income, and applies that to your actual income for that particular household that we had from concept 1. So you get these two values, and you reduce your VMT as needed so that the costs stay within the budget.
That should say 30% for lower incomes, 7 to 10%.
Okay. Thank you, Brian. 30%. That'd be a lot of travel up there. Okay. And then, of course, we go and we adjust the actual VMT that happens in the household as a result of this. So, okay. Cautions about where you can and cannot use this model. I think we've hit on some of these. It's not a project level, it's a policy, and policies in categories. It's good for resilience testing early when there's lots of unknowns. These are behavioral, do have some feedbacks, but there are limitations. So some of the, the land use is sort of fixed coming in. The vehicle mix, we said there's not much you can control. But there are some, and if you get, you can have a different schedule of the adoption rates coming in. Congestion doesn't feed back to your VMT. It slows your speeds down, and you have different emissions rate, but it doesn't impact the VMT right now. Spatially, there's no road network, so no specific policies. Aggregate congestion model, but I think these are important too. So we don't actually have, even though we have like a home and work zone, they are sort of like indicators. They're not specific O's and D's as much. So we can't really rely on those like we would with a travel model. And that gets to a little bit that like if I have, Corvallis and Albany, one's a bedroom community, and the other has the mall, and the third one has the university. So like those are all having intercity travel that this doesn't quite get to. This is going back to the NHTS and says the average place with characteristics of this type have this VMT. It's not knowing that your mall is, 5 B zones away or anything. So there's some limitations with that intercity that I think are important to point out. Okay, and then here's all the policy actions. These are out on the primer link that we said before, but they kind of roll all those things into one. These are the levers you can change. And the black ones are things that like we can't really change, but they will change without us knowing their uncertainties. The colored ones are sort of grouped into, like transportation modes or pricing are all in red. So anyway, you can look at that. I'm sure we'll have these slides out for you. And then these are the kind of outputs. And I should say, this is just one version of outputs. It's unlimited if you have R power. You can like go in and dive in, and we talked about some of that stuff. You could do it for EJ if you wanted to do that. But do keep in mind that this is strategic and first order effects. It's best to compare scenarios. Be cognizant of the level of aggregation and mindful of what is and isn't modeled.
All right, that's cool. So a couple of things here. We do have one final slide. There are a bunch of links. When you use the scenario builder functions within VisionEval, these are documented. We didn't go into that because it's sort of, you need to understand all the stuff we were talking about today before you drill down into that. And it really is just the mechanics of once you've selected what the inputs are you want to play with, you lay them out into a series of folders, just changing the inputs that are relevant to that scenario. And then you can set VisionEval going, and it will crunch through all the permutations and combinations, give you a pile of data at the end. All right, thanks everyone.